We're in.
Shall we play a game?
How about global thermonuclear war?
Hey there, HackerFrogs. It's me, the Shy Hat, and we're doing HackerFrogs After School today. We're doing HackerFrogs free hacking. We're hacking all the things. All right, it is getting pretty close to the midway point of March at this point, and today is March. Well, it says March 6th over here, but it's not March 6th. It's March 13th. I don't know why this date is incorrect. But anyways, what we like to do on each one of these live streams is we like to do a bunch of different topics over a series of, I don't know, something like 5 or 6 hours. And this is what we're going to be doing today. So for our first topic in our first hour, we're going to be doing programming. We're going to be doing some Advent of Code 2015. So that's a famous coding event that they do every Christmas. But yeah, we're going to be doing some old stuff over there from 2015. I think it's day number 4 we're doing today, and that's going to be our warm-up. We're going to be doing some Python coding. So in the second hour of today's stream, we're going to be doing topic number 2. We're going to be taking a look at TryHackMe data encoding, and we're going to be talking more about how data, basically strings of zeros and ones, become the things that you see on your screen. So that's going to be over at TryHackMe, and we're just going to be learning a little bit more about that in the second hour. In the third hour, we're going to be doing our after-school topic. So HackerFrogs AfterSchool is a little program that I dreamt up, and we're going to be doing our Python Basics course. We're doing session number 3, and today what we're going to be doing is we're going to be working a lot with strings. So people who do a lot of programming have to deal with strings all the time. Strings are little printable pieces of text that we can manipulate. And we're going to be learning how to do that in the third hour of today's stream. In the fourth hour of today's stream, we're going to be doing some file upload attacks. So we're going to be going over to another CTF platform, a cybersecurity learning platform called HacksMarter.
Hack the planet! Hack the planet! Shut up and get in.
Thank you very much, Agent 57, for redeeming the Hack the Planet redeem. Thank you. Okay, so in the fourth topic, we're going to be doing HacksMarter, and we're going to be learning about file upload attacks. So anytime a web application lets people upload files to the server, there is a potential for abuse. So we're going to be talking all about that in the fourth hour. And in the fifth and sixth hour, we're going to be doing some free challenges. So free challenge, well, it's not a paid challenge, and it's also going to be on a bunch of different topics, or at least we're going to try. We're going to be using the CTFLearn platform, and we're going to be trying to do some challenges over there and see what we can learn from doing the challenges. Okay, SysOS says string equals a set array of glyphs or characters, as in this is a string. It's called a string since it's a string of characters. Yeah, I mean, if you're dealing with technology, you'll learn the terminology pretty quick. What we refer to as a string is mostly printable characters that we can see on a screen. Of course, it's a little bit more complicated than that. Anyways, let's get into our first topic today. And our first topic is going to be our warm-up. We're going to be doing some Python programming over at Advent of Code. And you can find the website over here, adventofcode.com. And anybody can do these. Anybody can do these exercises. Crazy Gamer Studios, hello, nice to see you here. What is up? What is up? Okay, so let's put an hour on the clock, and then we will get started. Gotta click, click, click on the timer. Just a second. And here we go. I guess while we work on these, we can also put on a little bit of music. If you ever find the volume of the music too loud or too soft, please let us know in the chat. We'll try to adjust the volume as best we can. Okay, yep, doing the clock today. PPX, hello, nice to see you here. How's your day going? Well, I mean, I'm just starting my stream right now. And let's see how the volume is going. Okay, that's, I think it could be a little bit softer. Let's set it down a bit. Yeah, that's a bit better. Okay, so let's go ahead and talk about what we're going to be doing in the coding challenge. Pump up the jam, of course, Agent 57. Falco says, would you consider TryHackMe a good page to start in cybersecurity? Yeah, I mean, I think TryHackMe is a pretty good place to start learning. You could also use Pico CTF. I also have a link over here that I recommend to people get into cyber. It really depends on what kind of role you want to get into, because the type of training you would do for cybersecurity really differs depending on what kind of job you want to get eventually. And yeah, so let's talk about what's going on in this code. So this is day 4 of Advent Code 2015, the ideal stocking stuffer. Santa needs help mining some Advent coins, very similar to Bitcoins, to use as gifts for all the economically forward-thinking little girls and boys. To do this, he needs to find MD5 hashes, which in hexadecimal start with at least 5 zeros. The input to the MD5 hash is some secret key, your puzzle input given below, followed by a number in decimal. The input to the MD5 hash is some secret key, followed by a number in decimal. Okay, so to mine Advent coins, you must find Santa the lowest positive number, no leading zeros, 1, 2, 3, that produces such a hash. For example, if your secret key is ABCDEF, the answer is 609043 because the MD5 hash of ABCDEF 609043 starts with 5 zeros. Okay, so we're looking for a specific pattern, and it is the lowest such number to do so. If your secret key is this, then the lowest number it combines with to make an MD5 hash, starting with 5 zeros, is this number right here. That is the MD5 hash of this thing. Looks like 5 zeros and then a bunch of other stuff. Okay, let's see. SysOS says, everybody on Twitch, whenever the Shy Hat shows one of his lovely bird movies, share your love by spamming the bird emotes. The Shy31 bird. Share the love of the birdies. Hey, thank you very much, SysOS Master. Thank you. Okay, so your puzzle input is this. So I guess what we need to do is we need to start coding. And thank you very much, Drager TV, for following on Twitch. Thank you. All right, so I've got some code that I'm editing. Well, I've got a walkthrough document that I'm editing over here. And what we're going to do, thank you very much, Agent 57, for letting us know about the birds. Okay, SysOS says, I finally found a good... oh, the alternative is with the colon. Okay. Thank you, Agent 57, for the birds. Alright, so, I think what we need to do is, the first thing we need to do is we need to go into our Python code, and we need to start coding. So let's go inside here. I've got 2 terminal windows here set up, and one of the terminal windows we're going to be using to run our code, and the other terminal window we're going to be using to write our code. So I think the document we're going to be editing today is going to be nano-L, Advent Code 2015, day 4, and this is the A version, and this is a Python file, of course. Is that enough of the birdies? Yeah, thank you very much. Okay, so this is a Python file, and what we're going to do is we're just going to start writing our code. So I guess the first thing we want to do is we want to start defining our variables. So our key value is going to be whatever was assigned to us in the document. So in the document we got this. The puzzle input is this string. I guess another thing we need to do is we need to import whatever is going to be doing the MD5 hashing, because, well, Python doesn't do MD5 hashing on its own. Okay, so our key value is this. We'll import, I think it's called hashlib. Import hashlib, and I need to look up how to do the MD5 hashing, and then we need to look up how, yeah, we need to look that up right now. So let's see. Python hashlib MD5 hashing from string. Okay, Lucifer says, How do you decide which topic to teach today? I mean, I come up with a bunch of topics before the stream starts, so that's how I figure it out. If you ever want to take a look at what our schedule is, you can take a look at our Reddit or you can take a look at our Discord. They're going to be available on both of those platforms. Okay, so to generate an MD5 hash from a string in Python, you must first import the hashlib library and encode the string into a byte sequence before hashing. Okay, so what do we have here? Let's take a closer look. H equals hashlib new MD5. H update. Nobody inspects the Spanish repetition, of course. So what do they have here? Okay, so import the hashlib, and then we create a MD5 hash with a data string. Okay, I think. Well, I mean, we can copy the function, and we'll just go over what the function is doing as we create the code. So what do we have here? So this is a function, generate MD5 hash with a data string as the argument. Encode the string into bytes, for example, using UTF-8. So encoded string equals datastring.encode into UTF-8, and then we create an MD5 hash object and update it with the encoded string. So MD5 hash equals hashlib.md5 on the encoded string. So the first thing we do is we take whatever string, it would be a combination of the key value over here and some number, because that's what they wanted in. It's doing what I posted, but it's a nicer function for repeated use. Thank you, SysOS Master, much appreciated. And if you've got some suggestions for what we should be doing in this exercise, let us know. I might not necessarily use the stuff that you provide, but I appreciate the effort all the same. Okay, so the first thing we need to do is we need to turn the string into an encoded string. So this turns the string from a normal object into a bytes object. Encoded string is a bytes object. So create an MD5 hash object and update it with the encoded string. So it would be MD5 hashed, well, the encoded string hashed with MD5, and then return the hash in a human readable hexadecimal format. So return MD5 hex digest. Okay, Tugalander says, greetings fellow techies. Hello, nice to see you here. And Crazy Gamer Studios says, the Shy Hat, do you know how to encrypt Google files from anti-gravity conversations? .pb. I do not know about that technology, Crazy Gamer Studios. So it says, feel free to ignore any suggestions I give. I am here to help by offering options, not to be a stream dictator. I mean, yeah, thank you very much for understanding, SysOS Master. I mean, I appreciate all the people who give suggestions in the chat. Sometimes I just want to get the programming done my own way, of course. And whenever you have a bunch of programmers trying to collectively work on a problem, it can be very difficult to get people to agree. But anyways, so okay, so if we've got the key value over here, what we want to do is we just want to print out a sample MD5 hash. So let's just add the print statement down here. So print generate MD5 hash with our key value. Okay, so we'll save that out, and then we'll go over here and we'll run the script. So Python AOC. Okay, so this actually produces an MD5 hash, or at least it looks like it. So that is great. There are about 1,001 ways to write most programs. You only need one that works. Thank you. Crazy Gamer Studios. Okay, all right. Thank you, sir. No worries, no worries. So from here, we need to refine what the function is doing, because we've got a very specific criteria that we need to achieve here. Oh, I'm running this in my localhost services window? That's not the way it should be. Okay, let's call this regular text editor. And this is nano. And we'll call this window our localhost services that we'll be using later on today. Okay, so what we need to do is we need to define a new function that looks for a specific pattern. So, I mean, we can talk about what we need to do for this particular program over here. We need to hash a string with a number. The resulting hash has to be checked. To see if it has 5 zeros at the beginning of the hash string. We have to return the original string before it was hashed. Do we need to hash a string starting with a number? No. You have to hash a string with a number appended to it. So for example, hash key 1, 2, 3, 4, 5, something like this. Okay, Lucifer says, I was watching your old sessions, I actually completed them all, right up to the gray hack section. Okay, you explained things very well, sir. Thank you very much, Lucifer, thank you. And Fire Dog, hello, nice to see you here. Okay, so let's get back to the program then. So we know this works, so we don't need to print this out anymore. So I guess what we need to do is we need to write a little for loop. So I wonder how many values we should check first, because we need to do this a bunch of times, and each time we run the hashing function, we need to check the resulting hash to see if it has the required. 512 seems like a good value. I mean we can try this a number of times. We'll see if we reach whatever string we need to do first. So we'll do 4i in range, and I guess our range will be something like, I don't know, let's start with 1,000 numbers. So 4i in range 1,000 will do. We'll define our combined string. The combined string is going to be the key value appended to the string of I. Okay, so this should result in like a string like this value plus 1, this value plus 2, that, etc., etc. And then we need to do something to it. Oh, you know what else we need to do? We need to fix up our indents, because I prefer to do indenting with 2 spaces instead of 4. And this really matters inside of Python. Okay, so for I in range 1000, combined string equals key value plus string I, and then we do I guess we'll call this the hashed string, and this will be the result of generate MD5 hash with combined string. And then we need to do the check. Only if you want your program to actually run. That's true. I mean, I think I'm gonna get rid of these other spaces over here as well. Okay, so combined string equals key value plus string I, and then hash string equals generate MD5 hash, that this function with combined string, and then we need to check for the pattern. So if, so we're looking for 5 zeros in a row. 1, 2, 3, 4, 5. If 5 zeros in hash string, then we need to the answer. So the answer is going to be a blank string, and we're just going to fill in the answer if we find the requisite pattern in the hash string. Actually, we need to make sure that it has to begin with this pattern. So how do we check? I need to check really quick how we do like string matching at the beginning of a string. Python string matching beginning of string. What is your opinion on vibe coding? I think you can certainly get a lot of good stuff done with vibe coding if you know the language you're vibe coding in, and if you don't know the language that you're vibe coding in, then you have no idea what's actually going on with the code, and that can be dangerous. So, but if you're very familiar with the language that you're vibe coding in, it can be a method to get working code very quickly. The reason why you need to be familiar with the language that you're vibe coding in is so that you can do your own debugging if the code that the AI gives you is not good. Vibe coding is an excellent way to introduce logic and security errors. I mean, the other thing about vibe coding is that you shouldn't do it for large code bases. Using it for snippets and using it for boilerplate stuff is all right. But the more complicated the code is, the less valuable vibe coding is. But that's just my opinion. In Python, you can match the beginning of a string with the built-in starts with method. Okay, so we just do starts with, and then we supply the string, right? So if starts with, is that how you spell it? Oh, there's no underscore. So if starts with 00000 in hash string, then we need to update the answer. The answer equals hash string. No. Yeah, hash string. It's Python, not PHP. Is it not going to... Oh, PHP likes the underscores. Yeah, okay. So I guess we've got a little for loop here, and then we do the check. And if the check goes through, then we stop. We break. Okay, and then I guess we'll print... the answer equals the hash string, and I guess we can just do like return the answer. Yeah, so return the answer, and that'll break out of the loop. So no, we can't use return because this isn't a function. The answer isn't in the function. We just need to print the thing over here. So print the answer is the answer, and then break. Okay. It's if hash string dot starts with. If hash string dot starts with, is that the way we need to do it? Let me just try this one to see if... Nope. Starts with is not defined. Okay, so if... So Nurux, hello. If hash string dot starts with. If hash string dot starts with, 1, 2, 3, 4, 5. Okay, and we'll see if this works. Ah, okay, so it looks like we weren't able to find the answer within 1,000. So we'll just expand it out to 10,000, and then we'll try it again. Okay, so still, I guess we should also put in like, so for ion range, and then we'll print out another thing. No answer in range. Okay, and then we'll run it again. Huh, it ran, okay, okay. So it should be like the like an if else in here. So for ion range, let's expand it out to 100,000 and then do it again. Okay, and 100,000 was not enough, but Nurex, hey, thank you very much for the help. Otherwise, I would have had to go and Google around for the answer. Okay, let's do. Is that 1,000,000? That is. Yeah, so we're now testing 1,000,000 numbers. I think the else and break with the no actual answer in range would be okay. Else and then break. Okay, we found an answer now. So we've got, but you know what? Just for fun, let's see if we can get like a proper one. So if hash string that starts with the answer equals hash string, and then down here, else. I guess what we need to do, what I would like to do is I'd like to do this thing over here. So for break, so it breaks here, but we want to check. I mean, the other thing is that we could also turn this into a function. Was it ever hard to code live with an audience? It's always hard to code live, because anytime you code and you're not able to get the thing done, then you feel like you're not doing a good job. We got ads running on Twitch right now, so we're going to take a little break while we put on the birds. And, well, this one isn't a bird, but this one's a happy little squirrel. So, I don't know if I've got a squirrel emote or not, but here's this happy little squirrel. We'll be back in about 30 seconds. I just need to take a little water break. Okay, thank you very much, everybody, for for giving the bird emojis in chat. Thank you. Okay, we'll put the squirrel away. We'll get back to our code and stuff. Okay, so for ion range, the answer equals this. I guess we can also. So this. I guess we just need to do like a check here. Down at the bottom of the code. So if not the answer, if not the answer, I mean, we can't. So this is kind of like a code block here. So we can't really. Actually, you know what we can do? We can define the answer up here. So the answer equals empty string, and we'll just remove the answer from this code block. And then at the bottom here, if not the answer, then we can print no answer found in range. No match found in range. Something like this. Okay. It's not kind of like a code block. It is a code block. Yeah, for sure, for sure. Okay, not the answer. Well, I guess we can't do it like this. If the answer is a blank string, I guess we could do it like this maybe. Okay, the answer is this. We just need to rewrite this so that it doesn't come back true, and then try it again. No match found in range. Okay, so this works. So the program works. We just need to supply the answer. So the answer is, well, okay. The answer is we shouldn't be returning the hash. We need to return the value. So I guess so the answer equals combined string. Okay, and that should be the answer we're looking for. It is the code block. Yeah. And Pradeep, hello, nice to see you here. Thank you. Okay, so let's write that out and then let's run the code again, because we're looking for this. So we've got our key and then our number. So we'll just copy this and supply this as the answer. Where are we? Day 4. Answer pasted in, submit. That's not the right answer. That's not the right answer. Okay, so what? Let's look over the instructions one more time. If you're stuck, make sure you're using the full input data. There's also some general tips on the About page. And there's also hints on the subreddit. So let's take a look. Something's going wrong with our code. He needs to find MD5 hashes which in hexadecimal, okay, start with at least 5 zeros. Start with at least 5 zeros. The input to the MD5 hash is some secret key. The MD5 hash that's provided here is like a string of random characters and then a number. I mean, the pattern looks correct. And then we tack on a number over here, right? And Loris, hello, nice to see you here. What is up? Okay, so it has to be the lowest number that results in 5 leading zeros. So let's double check the output here. So the answer is the answer, and then we'll also print out this is the hash value, and then insert the what was it? The hash string. Okay, and write that out. We'll try it again. This reminds me of that I have to practice algorithm problems for technical interviews. Okay, so the answer is this thing, okay? This is the hash value. We've got 1, 2, 3, 4, 5. Yeah, I'm not too sure why this is going wrong. Because we did find the number that starts with the 5 zeros. Or the value that starts with the 5 zeros. I mean, another thing we could do is we could create a little dictionary here. So matching dictionary is going to be a dictionary that's empty, like an empty dictionary. Then we need to populate it. So if hash string starts with this, then, I mean, we could add the answer to there, and we'll just take away the break statement. Actually, we'll get rid of this portion for now. So just comment it out. And instead we'll do something else. So we'll do matching dict equals, how do we add a value to the dictionary again? It was Python add value to dictionary. Okay, assignment operator and the update method. So let's see, we do my dictionary equals this. Add a new key value pair. So add a new key value pair. So just my dictionary and then refer to it by the key. So matching dictionary equals hash string. So we add the hash string, we also add the combined string. And then at the end of the program, we'll just do a little print. We'll just print out the, I guess at the end of the for loop we can print out the matching dictionary. So print, actually, I guess in this case we should probably also put the matching dictionary outside of the for loop so that it can access it after the thing is done. Okay, get rid of this. And then down at the bottom of the program, just print out the matching dictionary. And I guess we can run it through like maybe this many. Who needs access to my dictionary after I freed it? That's that's a fun programming joke. Let's run the code. So how many? I mean, it's still running. How many millions are there here? It's like we've got a bunch of them now. So the first one that appears should be this one. So 28, 27, and then there's a bunch more that that match. It's a use after free cybersecurity joke even. Yup. All right, so let's copy this. Are they looking for the number, or are they just they're looking for the whole thing, right? So if the secret key is ABCDEF, the answer is 609043, because the MD5 hash of this starts with 5 zeros, and it is the lowest number to do so. So I mean, I guess the other test we can do is we can test to see if the examples come out with the same stuff. Because if they don't come out with the same stuff, then it means that our programming code is flawed. So let's try it with the other keys then, right? So A, B, C, D, E, F. We'll just test it with our program to see if it works. So we'll change it back to our original, to the original version of the program without the matching dictionary. So get rid of this. Get rid of a couple zeros here. And okay, so let's try our original program again with the test values. So the test values is this one over here, A, B, C, D, E, F, and run that code. No match found in range. So what do they have it as the answer here? So this is like, this is before 1 million. So we need an input range of 1 million. So we need an extra 0 here. Okay. So run the code again. So A, B, C, D, E, F, 609. 609043. 60943. So we got the correct value for the test. Let's check the second test to see if we got if we get the correct value for that. So over here, we'll change the value of the key and run the program again. No match found in range. Let's expand the range. And try it again. Okay, so we found the answer is number 1048970. Yeah, so our tests they're working with the examples here. So I wonder why it doesn't accept the answer for our key here. I'm just gonna try this again. We'll do a double check. I'm not too sure why it's not working here, but let's input our actual key and run it again. Oh, I forgot to add this. If the answer equals empty string. Okay. Copy paste error? Possibly. So 28749. Okay, and we'll go back and we'll submit the answer. That's not the right answer. What's wrong with the code? I mean, the test inputs, we got the correct answers with the test inputs. Okay, so let me... Oh, are we actually supposed to be submitting the... Are we supposed to be submitting the hashes themselves? Oh, we're submitting just the number. We're submitting just the number. Okay, no. I'm submitting the wrong part. The only thing we need to submit is the number. Okay, let's submit the number. I gotta wait 7 seconds to... Yeah, okay. So the answer is the number. The answer isn't the whole string. That's the right answer. Okay, I thought it was going crazy there. So the problem is that I was submitting the wrong format. So they weren't looking for the whole thing. They were only looking for the number value. Okay, so the answer is actually going to be... So the answer is not the combined string. The answer is actually the value I. Okay, and Puzzle input is not the answer. The answer, yeah, they're only looking for the number that we need to append to the key to get the answer. They're not looking for the whole string. Okay, so that's done. I mean, I'm not sure if we're going to be able to get the second part of the challenge done before we run out of time, but I guess we can copy our code that worked, and we can submit it. Well, we can put it in our write-up. So yeah, I mean, the important thing when we're dealing with questions like these is that we know exactly what format of answer they're looking for. Anyways, this is Python code. Paste in the Python code. Commit these changes. Okay, and then we'll move on to the second part. So for the second part, I'm just going to copy the entire... I'm just going to copy everything here, and I'll use this null adjusted afterwards. Okay, cancel the changes here, and then make the new thing. So the new one is going to be day 4. Wait, what does the format look like? Yeah, day 4 part 2. Not part 3. Okay, so I'll just get rid of everything here. And I'll get rid of the instructions because we have new instructions for this next part. Okay, so we'll go on to part 2. So the first half of this puzzle is complete. It gives 1 gold star. Now we need to find one that starts with 6 zeros. Is that it? Okay. I mean, what we need to do doesn't change very much, but I guess the computation becomes much harder. We have to look through a much larger data set in order to find our answer. Okay, I mean, what we've got currently should be fine. But we just need to add on that extra 0. So, I mean, this becomes hard because it's going to be improbable that we find an answer. So how many zeros do we have here? So this is like 100 million that we're searching through. That's going to be kind of tough. But anyways, let's... Oh, thank you very much, C. Strasser. Thank you. So we can just run it through this. And let me just check that we've got Okay, we found the answer. So the answer is this thing right here. I mean, if this is actually the way we do this challenge, then it's a bit underwhelming, the difference between part A and part B. That's the right answer. Okay, I mean, we're finished with day 4 now. Maybe we can start on day 5. Okay, and we'll record the code. It's also just day 4. I mean, I feel like some of the other... day 3 was harder than today's challenge. Day 3 was dealing with coordinates and populating a list of coordinates and getting the unique ones. This one seemed a little bit too easy. But, I mean, that's okay. So they're not all going to be, super complicated. Anyways, let's go ahead and commit these changes. and then we'll move on to the next day. So now we're doing day 5. So let's see, this one will be called day 05, part 1. They have easy challenges right after hard ones. I mean, I guess that's okay. It's okay. Let's see. So the URL for the challenge, we need to record that. The instructions. Actually, no, the concept. The concept for completing the challenge, the instructions, and the last thing we provide is the code. So let's get all that. So let's do day 5. Okay, and let me just get the URL to record it. And let's read the instructions. So let's see. Day 5. Doesn't he have intern L's for this? Santa needs help figuring out which strings in his text file are naughty or nice. A nice string is one with all the following properties. It contains at least 3 vowels, A, E, I, O, U only, like... It contains at least 3 vowels. So let's see. So it has 1 vowel here, 1 vowel here. So I mean, I guess we're counting vowels. We're counting, like, you know, different little strings. It contains at least 1 letter that appears twice in a row, so double letters. It does not contain these strings. So we're looking for doesn't contain these strings. Okay, so I guess we need to identify the nice strings, and if a string is not nice, then it is automatically naughty, so we sort them out. Okay, how many strings are nice? To begin, get your puzzle input. Okay, so let's copy the instructions. And we'll put them in our write-up here. So the concept we're dealing with in this challenge is we're doing some string matching. String matching with multiple criteria. Okay, and let's dive into it. So the first thing we need to do is we need to get the puzzle input over here. And let me just copy all of this, and then we will create a file called input.txt or something. Okay, paste this all in, and then alright, so we've got our input.txt file. We also need to get a little snippet that can handle using the file input as like strings, maybe? Yeah. So this is going to be AOC 2015 4 part A, and let's do this with some lines. Oh wait, this is day 5. Yeah, this is day 5. Okay, so we'll save this as day 5. (2015) day 5 part A. And then get into it. Okay, so I mean, we just need to get rid of everything here. And then I need to grab the snippet from my code from previous days that deals with parsing the file input. Hold on. So this is advent to code 2015. I think day 1 had this stuff too. Okay, so this is my snippet that grabs the stuff. Okay, and then go back. So file path equals input.txt with open file path r as file. raw input. Okay, let's adjust these indentations. And let's print the raw list. So what we're essentially going to be doing here is we're going to be iterating over all of the strings we input from the file, and they should be strings. So we're just gonna check that that list looks okay right now. Oh, this is not what we wanted. Okay, so raw string equals raw input. So let's just check the raw input here. So the raw input is a bunch of strings, but each one of these strings has the new line attached to it. So we need to scrub the new line off of these, off of the raw input, because we're not checking, well, we don't want this new line character here. So raw string equals raw input, and then we can do some string splicing. So it's going to be start at 0, stop at negative, like -2, -2. Search replace n. I mean, we could do that. We could also do the string splicing. We'll try printing out the raw string, and we'll see if it's managed to come out okay. Wait. Hold on. This isn't gonna work. Yeah, this isn't gonna work. Okay, so raw string. I think what we need to do is we need to create a new list and then populate it with like a for loop, right? So for I in raw input. I guess we can also define the formatted list. Format list equals empty list, and we'll just populate it with the for loop over here. And QVQ, hello, nice to see you here. What is up? What is up? So for I in raw input, format list dot append I -2, like this. And then at the end of all that, we can print it out. So print format list, just to make sure that everything went over okay. Okay, and write it out, try it again. Okay, so it looks like we've got the correct format for all of these strings. So just to make sure that this went over okay, I'm just going to do this instead. And we should see that all the slashes are there. Huh, that's weird. So this one ends with a CY. Oh, that's odd. I guess the for the context of like string splicing, the new line character counts as a single character. Okay, so let me just check this against the last thing in the input list. Okay. Yeah, okay, so this matches. So we've got the correct list of strings. So we just need to write up like a little function. So we got our format list over here. I like to put my variable definitions at the top of my scripts, and then I do my function definitions after that. So we'll define something like is is nice. So is nice is going to take in a string. Is going to take in a word string. You mean like a sane person? Well, I mean, some people don't. Some people have different standards. Okay, so is nice word string. Let's see. Return true. Actually, no. Is nice word string is going to add 1 to nice words, and nice words is going to be an integer, because we need to. Those people cannot program in C. So nice words is going to start at 0, and each time we return true with is nice, we're going to increment 1 for nice words. So what is the criteria? So day 5. So a nice string is one with all the following properties. Contains at least 3 vowels. So we need to I guess we need to define the vowels in here as well. Vowels is going to be equal to a list, and the list is going to be, I guess we can define the vowels up here as well. There's there's 5 of these. A, E, I, O, U, and the other thing we need to be sure of is that everything's in lowercase. So let me check the input. So it looks like the input strings are all lowercase, so we don't need to worry about uppercase and lowercase shenanigans. Okay, so we got our vowels, and I guess we should also define some of these other ones as well. So let's see. Contains at least 1 letter that appears twice in a row. So we need to check somehow that we've got like double letters. So checking, I mean, that can be in its own little function as well. And Brouhaha, hello, nice to see you here. What is up? I'm just doing some programming for the next couple of minutes or so. Then we're going to move on. Contains at least 1 letter that appears twice in a row. I guess that's going to be the other. We need to define another function. Has double letters. And has double letters also takes in a word string. And let's see, if so how do we let me look up really quick. Python string match double letters. Okay, you can match double letters in Python using a simple loop, the zip function. Using a loop, I guess we need to just check that the value of one of the elements is the same as the next element, right? So something like this. Have you heard of The Farmer Was Replaced? It's a game on Steam. I could see you liking it. We have done The Farmer Was Replaced for a couple of streams, but I think it's not quite as fun as working through like different problems each time. The problem with doing The Farmer's Replaced is that The Farmer's Replaced has us solving the same kind of problem each time. I understand that the visual aspect is a little bit nicer than solving like LeetCode problems or like these Okay, so I think, well, we're just going to put a pin in it for now. Cycle through each element and compare it to the previous. If values match, double letters. Randolph Stokes, hello, nice to see you here. What is up? But yeah, I think that's kind of like what we're doing in this function over here. Anyways, I'll just cat that out, and we'll just add it to our code right now in our walkthrough, and we'll come back to it next week. Okay, so here. Okay, we'll just put in our Python code, work in progress. Okay, and then we'll save it out. Yep. We're moving on to the next thing. Okay, so let's go ahead and move on into our next topic. So the next topic is going to be TryHackMe data encoding. So this is, we'll put an hour on the clock. And let's go over to TryHackMe. All right, so TryHackMe has a lot of great free stuff. I mean, I don't mind paying for some of the stuff over at TryHackMe. They've got a lot of good stuff. But let's log in. Not a robot. Thank you. Okay, and this one's called data encoding. Here we go. All right, so we're going to be working through this room over here. And let's see. Okay, to access material, start machines, or answer questions, you need to join the room. So we'll join the room. We've got the link that we just shared in chat if you want to check this out yourself. So we're going to learn how computer encodes characters from ASCII to Unicode's UTF. Great. So task 1, introduction. In the previous room, you learned how numbers are represented in the computer as binary digits, that is bits, and how these bits can be grouped into hexadecimal digits. We also explored how to express colors using numbers. Now, if everything is stored as numbers, how do we convert them into letters, punctuations, and emojis? So in this room, you will learn that characters are just numbers with agreed meanings. So that agreement is called an encoding. Let's make this a little bit bigger. Okay. Have you ever opened a document, visited a web page, or downloaded a movie subtitle files only to see that the file appear as weird gibberish? One reason for that is that the user who saved the file and the user who opened it are using different encodings. So, I mean, I'm sure you've seen stuff like this before. You expect to see stuff that you can read, but you get stuff that you can't read. Okay, so representation is the idea that data lives as bits and numbers in memory. At the same time, encoding is the specific agreed upon mapping between numbers and meanings, such as which numbers correspond to the character A. In text, each character, like Q5 or exclamation point, is assigned a numeric code. Skill issue, of course. So a string becomes a sequence of numbers that the computer stores and moves around like any other data. Okay, so our learning objectives for today. Upon completion of the room, you will learn about ASCII, Unicode, UTF-8, UTF-16, and UTF-32, how emoji is encoded, and what causes weird gibberish characters. So prerequisites. To make the best use of this room, it is essential to have finished data representation room. Okay, so we did that last week, I think. It's time to dive into encoding. Check that off. Okay, so task 2, ASCII. We already learned that digital computers only understand zeros and ones, starting from 0 and 1. How can we save and display text? So for example, how can we save the text TryHackMe in a file? What will such a file contain? So to be able to answer this, we need to agree on what bits represent the capital letter T, what bits represent the lowercase r, etc., etc. So let's all say that we agree to represent T with the following stream of bits. So it's this binary string here. Then all computer systems will store T, capital T, the same way, later when a computer encounters this, it will recognize this as T. Of course, we need to do this for all the letters in the alphabet, all digits and special characters. This approach requires a standard that computer manufacturers, designers, and programmers agree to adhere to. One of the earliest standards for English letters was ASCII. ASCII stands for the American Standard for Code for Information Interchange, and it is early character encoding from 1963 that uses the numbers 0 to 127 to represent English letters, digits, punctuation, and some control characters. Remember that the A stands for American, as this will come in handy later, but you might have noticed the original ASCII was limited to 7 bits. ASCII acts as a small bilingual dictionary between text and numeric codes. Consider the following examples from the original ASCII table. Since the table has 128 entries, we only made a brief selection to give you an idea of how things are represented in ASCII. So for each character in the ASCII encoding system, we've got decimal representation, hexadecimal, binary, the symbol that is being encoded, and the description. So we got decimal 48, which is hexadecimal 30, binary 00110000, symbol is 0, description 0. So this goes on for all of the encoded characters. Okay, so there are several things that you need to observe. First, the letters are in order. If you know the hexadecimal or decimal order for number for B, you can figure out the decimal number of the lowercase a, the lowercase c, and later lowercase letters. Okay, same thing for the uppercase characters. Okay, when using ASCII encoding, a computer system reads 41 in a file and displays A on the screen. When it reads 42, it displays B, and so on. So the interesting thing we need to understand about this is that these are not decimal numbers; these are hexadecimal. But secondly, each character has its own ASCII. For example, square bracket. This is left square bracket is represented by the hexadecimal number 5B. So TryHackMe and ASCII. Let's say you open a text file and write TryHackMe and save it as file.txt. How will the file look on a bit level? Let's find out. If you're interested in seeing the storage on the disk bit by bit, and assuming that it's just using ASCII, you will see something similar to the following. So this is one character, and then the next character, and this spells out the word TryHackMe. I think at the end of the file, there's going to be a new line. So the /n. Terrence, hello, nice to see you here. What is up? Okay, obviously this is not readable by any human being. These are the exact binary representations of all the letters in TryHackMe followed by a new line. When you open this file, your editor will read these bits and display the following characters: TryHackMe, and then the new line. The new line is a new line that you get when you hit the enter key. So because reading binary numbers is cumbersome and error prone for us, we prefer to use hexadecimal digits. As you remember from the previous room, we group 4 bits into a single hexadecimal digit. Our file looks like this in hexadecimal. So 537279, etc., etc. I mean, we can probably demonstrate this right now. So if we go over to our terminal and we're done with this. Okay, and we write out a TryHackMe to a file. Let's see. Test.txt, like this. If we take a look at this file, test.txt, inside of like a hexadecimal like a hex dump program, like XXD, this is exactly what we see. So this is hexadecimal representation 54727948, which is the same as what we see up here. And it ends in the 0A, which is the new line character. which we also see in here. Okay? So if you wanted to look up the decimal representation, it would be as follows. So it would be these numbers. These numbers are translations. So these are hexadecimal digits, and these get if you convert hexadecimal to decimal, 54 becomes the number 124 in decimal, and this basically maps onto this entire series over here. However, it is uncommon to use decimal digits. It is more common to use hexadecimal digits when we want to show the bits. Okay, you can use the attached static site yourself to experiment more. And I think they're talking about task includes website. Okay. So where is the website opened up? Hold on, I need to I'm not too sure. Task includes website. Can we put the website in a new page? I don't think we can. Huh, where does it appear? Does it appear? Because I clicked on the thing. Oh well, I guess I'll go looking for it later if we really need it. It will be in the page. Oh, it will be in this section? Maybe try reloading the page. Okay, let's reload the page. Yeah, that's weird. I don't see it pop up. Maybe because is it because I've got like pop-ups disabled or something? Because nothing really happens when I click on this thing. Oh, view site. Okay, okay. Click on the view site and then answer the following questions. All right. All right. Awesome. Okay, and before we do this, let's go ahead and read this section here. I see a gray or green view site button. Yeah. We'll open that up after we read this section here. So European languages. ASCII provided a way to encode English, the English alphabet. However, we need to encode to support other European languages such as Spanish or German or Polish or Czech and Romanian. We need to include extra characters. So ASCII uses 7 bits, and with an 8th bit, we get 128 more characters to cover. However, the reality is more challenging. The additional 128 characters are not enough to cover all of the letters of the European languages. The ISO IEC 8859 series created several standards. Each standard covered a set of languages. So ISO 88591 is Latin 1, and it covered Western European languages like German, French, Spanish, Italian, Portuguese, Catalan, and the Nordic languages. ISO 8859-2, Latin 2, supported Central and Eastern European languages like Polish, Czech, Hungarian, Croatian, Romanian, and Slovak. So in other words, if your document is saved using ISO 8859-1 and later read and displayed as if it were saved using ISO 8859-2, non-English letters are likely to be displayed differently, okay? So SysOS is a part of the English alphabet. It forgot about half of them, like typewriters do or did. Okay, click on the View Site button and use it to answer the following questions. What is the ASCII code in decimal for the @ character? Okay, so let's go ahead and open up the website. I think you can do it. Show split view. Okay, so we need to go in here and type in the character we want. Like this. Okay, so let's go ahead and answer the questions. Where are we down here? Okay, what is the ASCII code in decimal for the character at? So this is the at symbol, yeah, and then the decimal value is 64. 64. Okay, that is correct. Great. SysOS says I typically use ISO 8859-1 for Dutch. So that's the first standard for Western European languages. CJ Web Design, hello, nice to see you here. What is the character that has the ASCII code of 35 in decimal? So we can go in here, type in 35, and we got the hashtag. Number sign, hashtag, okay. So just type it in. Done, okay. What is the name of the character that has the ASCII code of 7? What is the name of the character that has the ASCII code of 7? I mean, are we talking about 7 decimal? Or are we talking about the number 7 here? What is the name of the character that has the ASCII code of 7? I think they're looking for... Okay, so let's see what 7 is in decimal. So 7 is bell or alert. I mean, I guess when we're talking about stuff that's below the number 10, it's going to have the same code regardless. Okay, so this is bell. Pound sign. BEL. Okay, so we'll move on to the next section. So the next section is talking about Unicode. Where is it? Here it is. 7 is decimal, hexadecimal, it's all the same thing, yeah. So Unicode. We learned that ASCII is a 7-bit standard that defines 128 characters covering English letters, digits, and basic punctuation. We also noticed how ASCII, with its 7 bits, didn't have room for characters such as N with a... What is this symbol called again? It's like... It's some sort of accent. Okay, it doesn't have room for the euro sign. It doesn't have room for the Japanese hiragana alphabet. Or I'm guessing this is Arabic? Is this Arabic or some other symbol? I'm not sure. Using 8 bits, Extended ASCII tried patching this with regional variants. So it's got ISO 8859-1, 8859-2, Windows 1252, among others. But this caused chaos. For example, the sender writes and saves 0 with the slash through it using ISO 8859-1, Latin 1, and the recipient opens and reads the document using 8859-2, then they'll see a different character. So hence it is clear how opening a document requires us to use the same encoding used when saving it. Otherwise, various characters will not be displayed correctly, or even more confusingly, they might be incorrectly replaced. Omar Badran says, basically B in Arabic, pronounced ba. Oh, this character? I mean, I learn a lot from interacting with the live chat, stuff that I didn't really know before. But thank you very much. And I guess I did guess correctly that this was Arabic. So unlike English, which has 26 letters and needs 52 characters to cover uppercase and lowercase letters, Arabic needs more than 250 characters to cover its various ligatures and diacritics. Thank you very much, Eris44J, for following on Twitch. Thank you. Moreover, the number escalates rapidly when considering Japanese and Chinese. In Japanese, 2,136 kanji are considered daily use characters, as mandated by Japan's Ministry of Education, and in fact, the JIS X0208 standard defines 6,879 characters. In Chinese, educated natives recognize around 8,000 characters. Furthermore, the GB, this number, defines more than 87,000 some odd Hanzi, which is Chinese characters, And still, we have not considered encoding emoticons, emojis, okay? It gets more complicated after this. In other words, it is essential for both the sender and the recipient to use the same encoding. Moreover, we need an encoding that can include all the characters from all languages. This situation brings us to Unicode. So Unicode is a universal character encoding standard. It assigns unique code points to characters from all modern and historical writing systems worldwide. Unicode supports the interchange, processing, and display of text in diverse languages. SysOS says, or all possible notations used in all fields. I mean, I think they deal with a pretty large space in Unicode, but let's continue reading about this. In other words, we don't need to worry about picking a specific encoding standard that is compatible with the languages that we are using. Furthermore, this makes it easy to use different languages in a single file or message. And most importantly, this is a standard that fits all. We don't need to worry about encoding used by the original author, as they will also be using Unicode. Okay, Unicode is a character set standard that assigns a unique number to every character across all languages. For example, Unicode 41 is the Latin A. Unicode, I guess these are hexadecimal digits, right? So Unicode 03A9 is the Greek omega symbol, and Unicode 3042 is the Japanese hiragana A symbol. Unicode 17.0 is currently the latest version of the Unicode standard. It defines close to 157,000 characters. Almost 4,000 of them are emoji sequences. Okay, Hey Clip says, could you do tutorials on Pico CTF challenges? Are you talking about the current event for Pico CTF 2026 or other events? I'll get a Chick-fil-A party if I get the highest in my grade. Oh, you're talking about the current challenges. We can't do the current challenges because that goes against the rules. I'd say that if you do a bunch of challenges from previous years, you'll have a much better time doing the events from this year, because you see the same sort of patterns over and over again. Okay, so we're talking about UTF-8, UTF-16, and UTF-32. Because you encounter UTF-8, UTF-16, UTF-32, we'll briefly cover them without going into too much depth. What you need to know is that UTF-8 is very common on the modern web. It encodes Unicode points into the 1 to 4 bytes dynamically. In other words, it decides on the numbers of bytes based on the character complexity. ASCII characters from Unicode plus 0000 to Unicode plus 007F. They use exactly 1 byte, identical to the original ASCII, ensuring seamless backwards compatibility. Non-ASCII characters like Omega use 2 bytes, while complex scripts or emojis like fire require 4 bytes. Okay, UTF-8 is almost the same as ASCII extended. I hear that the character sets are very similar. I mean, I guess that's why UTF-8 and ASCII are so commonly used. So the flexibility allows us to cover the Unicode standard without wasting bytes. UTF-16 takes a different path. It uses either 2 or 4 bytes per character. Common characters like most Latin, Cyrillic, or Chinese Hanzi fit in 2 bytes. However, rarer ones like emojis or ancient scripts require a pair. That is 2 16-bit units totaling 4 bytes. For example, the letter A is encoded as U plus 0041, kind of like all the other ones, while the emoji fire needs 2 and is encoded as okay. So it takes 2 of these bytes. Burner email. Hello, nice to see you here. What is happening? So we're just we're learning about data encoding. So stuff like ASCII and UTF-8, UTF-16 over at this room over at TryHackMe. So finally, UTF-32 is the simplest but also the most wasteful. Every Unicode code point uses exactly 4 bytes. For example, A is encoded as all these leading characters and 41, and fire is encoded as this pattern over here. So I mean, I guess the problem with UTF-32 is that everything takes up more space and it requires more data than might be necessary to send the same amount of data or the same representation. Okay, so let's explore a few more examples. So this character is one of the Chinese characters that appear in offensive Linux distributions, such as Kali Linux. So this character means dragon. In Unicode, it has this code, or this code in UTF-32, I'm assuming, depending on whether it's UTF-16 or UTF-32. The smiley face is nothing more than UTF this code. In a UTF-32 computer, that's literally going to be this set of numbers, and then these other, what is this? Like leading zeros. So the Japanese letter tsu, which some people use as a smiley face in some regions outside of Japan, has a code of, so this is the UTF, this is UTF-16, and this is UTF-32. Yeah, okay, that's correct. Okay, so the Arabic letter ta, which is this one, and some people use it as a smiley outside of the Arab world. It looks close enough to a smiley face. From a Unicode perspective, that is U+062A. Okay, looks like our music has stopped playing, so I'm just gonna get the music playing again, then we'll continue. How about some random XCOM music? Here we go. Okay, so this last one is the Black Knight in chess uses the Unicode, this code right here, U+265E. In other words, the computer reads this set of zeros and ones and shows you a Black Knight thanks to Unicode. We have a static site to help you look up characters and explore new ones available in most standard fonts. So click on the View Site button and use it to follow the answering questions. So click on View Site. Okay, so here's the Unicode character encoder, and we'll answer some questions. Oh, I'm looking at the wrong section. Just a second, everybody. Okay, what is the UTF-32 encoding of the smug face? Is this a smug face? Everybody, let me know how you would describe this one. Okay, so we'll just plug in the smug face. It's just called Unicode character this, it doesn't describe it. Relaxed faced, is that what it is? Oh, this isn't the smug face, it's just like, yeah, okay, relaxed face, I can see it. So the UTF-32 encoding, so UTF-16, so UTF-8 would interpret this as 1, 2, 3, 4 different bytes, but UTF-32 would put it all in one. Okay, so this is what we're looking for. Paste it in. That's the face of someone that someone makes after they farted in their car after a date. Oh yeah, so they were holding in the fart before, while the date was going on. And In and Out, hello, nice to see you here, and thank you very much for the super chat. What's a good antivirus and malware program? In and Out, let me know what. We don't need to talk too much about farts in the chat, thank you. But anyways, so In and Out, let me know what operating system you're using, because my answer is going to change depending on whether or not you're using Linux or Windows. But yeah, let me know in the YouTube chat, In and Out. I mean, I'd say that if you're talking about like Windows, most of the time you just need to rely on the Windows Defender to keep malware away from your system. But I used to use Avast antivirus. So Avast antivirus, I think it's called AVG. So they're both owned by Gen Digital and share the same core malware detection engine. I mean, I'll get you an article. Windows 11 and Chrome browser. I want to know the answer for Temple OS, because that's the one OS that we don't know. I mean, do people write malware for Temple OS? That's a pretty good question. But thank you very much for your super chat, In and Out 3333. Thank you. What's the best IDE for use with Python? I mean, I don't do a lot of like IDE stuff for Python, but I hear that a lot of people like to use, what is it called? VS Code for Python. Okay, so that was the first question. Randall Stokes says, I used to use Kaspersky when it was legal. Is it? I guess it's not legal if you live in the United States anymore, huh? Okay, is it okay to use browser or desktop in Python? What do you mean by is it okay to use browser or desktop? Okay, let's see. C. Strasser says, Gemini states that the emoji is named Relieved Face. Relieved Face, okay. VS Code Nano, anything minimal, unlike JetBrains IDs for .NET stuff. Oh, okay. Yeah, it got... you're not legally allowed to use Kaspersky if you live in the US, because it's considered... it's part of the naughty list. Okay, what is the UTF encoding, 16 encoding for the she character? So in Japanese, this is the she character, and this is the su character. They look very similar. Okay, so let's go ahead and plug this in. This Japanese character, and we're looking for UTF-16. So in UTF-8, this is 3 bytes. In UTF-16, it is 2 bytes. Huh. That's interesting. So UTF-16 is a little bit more efficient in this case. I mean, UTF-8 overall is more efficient than UTF-16 because when it doesn't need to use, when it only needs to use 1 byte, it only uses 1 byte. Anyways, let's copy this. Okay, SecLife says there are some browser-friendly like Replete, and there's some desktop IDEs like VS Code and PyCharm. I don't know which compiler or IDE is the best to use. SysOS says, as always, the best IDE is the one that works for you. I mean, I don't have too much of an opinion as far as IDEs for use with Python, because I'm not usually working with very large code bases when I deal with Python. Usually the stuff I deal with is not very large chunks of code. Anyways, we've got our answer here. And the next question is, what is the character that has the following UTF-32 encoding? So I guess we can just plug this in. Oops. Okay, so it looks like this is this is the sunglasses emoji. The sunglasses emoji. What is the character? So I mean, how do we... It's looking for 2 characters here. In hexadecimal, like, I mean, I don't... How do we define this? So is it like 8 smiley face? Like this? No, this is not correct. Okay, an emoji is 2 characters. Just copy paste it. Okay, so copy this. So emojis take up 2 characters in the keyboard? Oh, okay. Okay, so what is the character that has the following UTF-16 encoding? So it's U plus 2658. B and parentheses, yeah. Okay, so I guess we will go down to UTF-16, plug it in. Ah, so is this the white knight or the black knight? Is this the black knight? They're talking about it. I mean, I guess we can just copy this. It's funny how, I mean, this isn't. People talk about how the emojis take up 2 characters, but this symbol isn't an emoji though. So I guess that's the difference. Okay, and the conclusion. So let's close this up. So conclusion, in this room we learned about ASCII and its limitations. We learned about Unicode and the 3 encoding standards UTF-8, UTF-16, and UTF-32, and we explored how Unicode enables us to cover not only the world's languages, but also symbols such as chess pieces and emojis. And it's also, it's the Silhouette Knight. It's originally from the ASCII set, so it has a low number. Oh, okay. I mean... Okay. So if you're curious how computers manipulate data, join the Python demo room. How computers manipulate data, join the Python demo room, coming soon. Okay, so I guess it's not here. Hey, we're done! Great. Okay, so, I mean, we've got like 20 minutes before we have to move on to the next topic. So I think we might be able to do some different stuff while we're waiting. I think what I want to do is I want to take a look at our good old fun website, Hack the Web, hack.arg.de. And I think we'll log in as our original account, the Shy Hat. We'll try solving one of these challenges we haven't done before. We've got a few more to do. Social engineer. Anyways, if you want to join along with us, this is the website over here. So let's see. We got guide, we got freedom, post it, say it, Oracle. We've got the community area over here. So I think I've tried this challenge before, this Oracle challenge. I'm pretty sure we got stuck. I'm gonna take a look and see what it's all about. Just a second, everybody. Oh, where's my repository? HackerFrogs. And we're doing a walkthrough for Hack the Web. And let me just get the... This is challenge number 90. Yeah, we've done this before, Oracle. So I didn't finish this, and I didn't write any notes for it either. I really should have. Let's take a look at it. Okay. Oh. Okay, I think I remember this challenge. So this challenge has to do with like, is this like a chatbot? Anyways, if you want to check this out yourself, you can check out this link, and you can use the guest account over at Hack the Web. So the username is demo, and the password is HTW123. If you want to check this out yourself. So talk to the Oracle to find the answer. There's only a period of 15 minutes each day in which the Oracle can speak. So I think the this challenge I think has to do with some manipulation of HTTP headers. So the Oracle is currently not available. Try again later. So I think in this challenge, what we need to do is we need to set the time manually through HTTP header. So for example, if we try to curl this, we send what do we send? We send this information here. So get HTTP2, challenge Oracle, and then user agent, and then accept. I think what we need to do is we need to manipulate our date to include the server sends the time, we do not. I mean, there has to be some way to send the time as part of the HTTP request, because otherwise we wouldn't be able to get this done. So the Oracle is not available again, and as part of the challenge it says the Oracle does not radiate energy. There's only a period of 15 minutes each day in which the Oracle can speak. Talk to the Oracle and find the answer. So we need to be able to manipulate the time that we send with our request. Cookie time, maybe? We do send that. We send cookie time? Mark Morente. Hello, nice to see you here. What is up? Dropping knowledge has helped me a lot. Yeah, I mean, if you're getting something good out of the stream, I am happy for you. And because that's what we're trying to do. We're trying to help people learn. So we do send cookie time. I mean, we send this information. We've got our certificates here. We receive a cookie though. So maybe it is the cookie that we need to modify. So the response is here. Let's take a look at our web developer tools, and we go to our storage. Well, I mean, this SID is our login information. And you know what? I think what we need to do is we need to, if we're going to start playing around with this, I should probably be logged in as the demo account and not my actual account, because my actual account. Well, why is this so intense for no reason? Okay, let's reload the page. The Oracle is conducting important business. Try again later. So, do we still have a cookie? Okay, we still have a cookie. Okay. I think I'll try accessing this page in a private window. Okay. Because we're hacking, of course. Deep meditation. Try again later. Okay, so if I go over to the web developer tools, so I mean this shouldn't have my login information anymore because I'm in the private window. But actually, let me try doing this on a completely different window to see. Try again later. Okay, so I mean each time you reload this page, you're gonna get a different response. Cookies. So let's take a look at this cookie. So set cookie SID equals this. So this is this SID. We need to understand what kind of format is in here, because I mean, if we're able to understand it, we might be able to make our own cookies. Saint of Vice, hello, nice to see you here. What is up? Okay, so I mean, there's a possibility this could be like a JWT, in which case we could go to jwt.io. I mean, this is just kind of like a long shot. Okay, the debugger is here. We'll just paste in. And let's see. I mean, I don't think it is. The other thing we could do is we could ask about this from our good friend the AI. What can you tell me about the format of this cookie? Okay, so this string is an express node.js signed cookie containing a session ID plus an HMAC style signature URL encoded. So this is a URL encoded S:, which is the prefix Express uses to indicate a signed cookie value. So decoding your cookie gives roughly this. The part before the dot is the underlying value for a session ID used by Express connect.sid or similar. The part after the dot is the cryptographic signature, HMAC computed with the server secret to detect tampering. Okay? So to unsign this cookie and retrieve the raw value, the server or your code must know the same secret that was used by Express's cookie parser. So I mean, I don't know if it's going to be this, because this seems a bit complicated. Not that the challenges by this point are not complicated. They can get pretty complicated. Hold on. Let's sign as the demo account. Okay, now that we're signing as demo account, where was it again? Oracle was like down here. Here it is. Okay, Skyrim Brook says, can you use Burp Suite to solve this? It's the one outside of the branch. Yeah, I mean, we found it here. So, I mean, I think we can get some hints, because I'm pretty sure I've been working on this for a while. So the hints are all going to be, oh, this redirects you to the Discord. So there's help here. Originally there was like a hint button here as well. My Oracle, which I commissioned for this task, does not radiate energy. There's only a period of 15 minutes each day. So I mean, my suspicion was that we were supposed to use some sort of HTTP header to send along with our request to specify a time. But I mean, that could be wrong. It could be that we're using the cookie to indicate the time, or something else. But, I mean, the question is, what do we have at our disposal? If we wanted to send time along with an HTTP request, how would we do that? I guess we want a few suggestions. Specific HTTP request headers, or something else. Okay, HTTP requests can include timestamps primarily through the standard or custom headers. The most common approach uses specific HTTP headers for time-related data. So there's the date header, okay? And there's other custom headers like X timestamp or X request timestamp or X time. Duck, hello, nice to see you here. What is up? We're just working on a little challenge while we're waiting for the next part of the stream to begin, which is going to be in about 10 minutes or so. Although it should start in about 5 minutes, realistically. So timestamps can go into query parameters or request bodies, so TS equals something. But headers are preferred for metadata without altering the resource path or payload. So no single timestamp header exists universally. Choose based on the protocol needed or the API specs. I mean, the other thing we could do is we could take a look at the source code for the challenge. It might have like a hint in here, or maybe not. If you want to take a look at the challenge we're looking at, I can give you the link. So just log in to here with username demo and password HTW123. So I don't think there are any hints here. Let's get out of it. Okay, let me go back and let me log in as my original user. Okay, we're looking for Oracle. Okay. So the Oracle is only available for 15 minutes each day. So, the only thing I can really think of is we need to fuzz the endpoint. So this endpoint over here, and we need to send custom HTTP headers. So the date header over here, we could try modifying this. So we could make something like, oh, interesting. We need to send a cookie with this request, otherwise we'll get a German response. Okay, so we need to, what was it, B for cookies? B, what is the name of the cookie? More tools, web developer tools, HTW language. HTW language equals EN. HTW language preference. Is that how you spell it? Okay, that's not that's not the correct one. So is it, oh, it's equals, right? HTW language preference equals EN, like this. Nope, that's not how you do it. So I just need to grab like a quick tutorial. Curl with cookie. It's like dash cookie or something like that. Dash B or dash cookie. So let's see. Dash B name equals value. Oh, I think I spelled the name preference incorrectly. You gotta spell everything correctly, everybody. Okay, let's just paste it in. SID equals, I don't think we necessarily need the SID equals. Okay, great, great. So this works now. I guess if you want to just send a basic thing. There you go. So the other thing we could do is we could start sending like a custom date header, and then like input a incremental like minute value inside of here each time, and just cycle through the entire thing. Okay, Duck says, I got 29 stars on my first ever project on GitHub. I'm really proud of it. Awesome, awesome, Duck. Yeah, I mean, if you want to share your project, you can let us know the name of the project in chat, and then we can take a look at it real quick. But if you don't feel comfortable sharing that, you don't need to, of course. Okay, so I think I mean, I'll put this challenge in another browser of mine so I can take a look at it later. But it looks like we're not going to be solving this right now, because we've got to move on to the next topic in a timely fashion. So let me just get rid of some of the tabs we're not using, and I'll just write a little note for myself here. So category is web app stuff. The concept is manipulating request time. Method of solve, we need to find a way to send a time value with our requests. We need to iterate through all the minutes in the day to see when the Oracle endpoint gives us a correct answer, I guess. Okay, Skyrenbrook says, I did a similar challenge decoding a Flask session cookie. Oh, awesome, Skyrenbrook, yeah. Thanto says, it's 5 in the morning, how is Mr. Frog streaming so early? I mean, it's not 5 in the morning where I am, Thanto, but welcome to the stream. YM Sniper. No Eyes YM Sniper. I think you talked about this one before, Duck. Yeah, this one. The security terminal-based chat tool. Oh, yeah. We took a look at this one before. So it's about chatting from server to server, or from client to client. It's like direct client chat tool that doesn't record anything. Is that yeah, secure terminal chat, end-to-end encrypted group chat, private messages, and file transfer right in your terminal. The server is a blind forwarder. It cannot read a single byte of your messages, even if fully compromised. I think it's an interesting tool. I wonder, do you use this this application to chat with your friends? Anyways, okay, let's get started with the next topic, or let's set up. So we're going to be talking Python. So we're going to be, where is it? Okay, we're going to be doing Python Programming Basics Part 3. And if you want to take a look at the stuff that we're going to be covering today, it's over at this markdown file on the GitHub. And let me reset the topic, and we'll put 60 minutes on the clock here, and then we'll get started. Okay, and let us begin. Oh, I need to change my overlays as well. Okay, so topic 2 is done, topic 3 is here, topic 4 is on deck. Thanto says, I didn't sleep last night. I was configuring my NeoVim the whole night. I mean, I hope you get some good use out of NeoVim if you've been spending that much time configuring it. All right, everybody, this is HackerFrogs AfterSchool Python Programming Basics Part 3. Let us begin. So what we learned before. So this workshop is the third intro class to Python programming. During our last workshop, we learned about a few programming concepts through Python, including the following. We learned about lists, which are variables with one or more items associated with them. Items in the list can be referenced by a process called list indexing. So if you ever wanted to follow along with us, try out some Python code, I've got a website called onlinepython.com. It's got ads, but it is definitely very handy if you don't have your own Python coding environment to work with. And let's see if we can make this a little bit smaller, a little bit smaller, a little bit bigger. Okay. Okay, so you can use this website even if you don't have access to any other method of writing Python code, and you can start writing the code in this window over here, in the main.py window. So for example, if you wanted to print out a message, HackerFrogs, like and subscribe. Okay, and then you can hit the run button and it'll print out that message. Hopefully it does. Sleep, nah, I'm a night crawler. Okay, so it does run the code for you, which is very, very nice. And it's available to anybody who wants to use it for free. Of course, if you've got access to like a terminal environment, it would be a lot better to just type out your Python code in there. But let's talk a little bit more about what's going on. So we learned about lists. Items in the list can be referenced by a process called list indexing. So you see here we've got vegetables. It's a list with carrots and lettuce and beets. If we reference vegetables in the 0 element, then it returns carrots, because counting in the list starts counting from 0. So this is element 0, element 1, and element 2. We talked about basic operators, which is what Python uses to do arithmetic operations. So in this workshop, we're going to be talking about string formatting. So string formatting and basic string operators. So what do these mean? Well, we'll explain it while we work through the lesson. So part 1, string formatting. So string formatting lets us use variables and strings, allowing for dynamic print output. So for example, over here, we got name equals the shy hat. So this is our variable, that's a string. We got daily coffee, which is a number of cups of coffee we drink per day. We're going to print name drinks daily coffee, cups of coffee a day. And we get our dynamic string output. We see the shy hat drinks 3 cups of coffee a day. So we'll talk about how we create these types of formatted strings. Rootzer says, VS Code has a lot of extensions for Python. I bet it does. CJ Web Design says, I'm running Python scripts right now for an e-commerce site and database with over 200,000 parts. 200,000 parts. I mean, I wish I could help you, but I don't really... I mean, I do understand Python programming to a degree. I wouldn't call myself an expert in it. And I certainly don't deal with like large code bases. But let's continue. So string formatting. So when formatting in this way, we use F strings. So F strings, we use them by including the letter F in front of the string when we use the print function. Oh, they're racing car parts. Okay. So we can do this ourselves. We can create some string formatting over at our online Python. So we'll just define a couple of things. We'll do name equals, I don't know, HackerFrogs. No, the shy hat. That's me. Okay, and food. Food equals... Oh, what do HackerFrogs like to eat? They like to eat salad. Salad, because salad is green and HackerFrogs are green. Okay, and we'll print out a little message like print with an F string. So when we want to use the string formatting, we have to put the F in front of the string here. And then after that, we can do name in between these parentheses. Likes to eat food. Exclamation point over here. And then we will print that out. Run it. The Shy Hat likes to eat salad. HackerFrogs eat all the bugs. Cybernerd Dante, hello, nice to see you here, especially the critical ones. What is up? Not flies or crickets? I mean, HackerFrogs are essentially just hackers. Anyways, so if we use the F in front of the string, then we can insert variable names like this. So in between the curly braces here, the name of the variable, and then we can insert the variable values. They're also frogs. They're hackers, and they're also frogs. Rootzer says there's no preferred IDE for Python. The most common is VS Code. I mean, use whichever IDE, whichever program helps you code the best. Do some experimentation. Danto says, I've never written any Python, Lua, or Bash code that exceeded 300 lines before. They are scripting languages. I mainly use them for boring stuff that I can automate. I mean, the best use of code is to automate processes that you would normally have to do manually, which was not very fun. So, yeah. So if there's anything that you need to do a lot of, you're probably better off using some code. Okay, so yeah, so that's one example of string formatting. And let's go back. Where are we here? Okay. So then inside the string, we can insert the variables into the string with the names of the variables wrapped up in curly brackets, which are the curly brackets, otherwise known as curly braces, or what else do you call those? Square? Well, they're not square braces. Anyways. Okay, we can also use list objects as part of F strings. So we've got list about frogs, and we got green and jumping. This animal is list about frogs element 0 and moves around by list element 1. This animal is green and moves around by jumping, so we can start using some list objects inside of our F strings. Is this also not called templating? Is it called templating? I mean, I guess we could call this string templates as well. I mean, that does make sense. So if we go back to the online Python here, we can write up a little list. What is this list going to be? About the Shy Hat, and it's going to be a list with some special things about the Shy Hat. The Shy Hat is HackerFrog, and the Shy Hat is oh, I don't know, CTF enthusiast. Okay, and these two things, we can put this in an F string. So print oh, I guess the first thing we would put in this list would be the Shy Hat's name. So the first element would be the Shy Hat. Okay, sure. Rich because it hauls all the monies. I mean, not right now, maybe in the future. In JavaScript, you would call this string template, so that's why. Oh, okay, okay. No worries. So, okay, so we could do... this person is named about the Shy Hat element 0, and then... and they are a... something. They are about the Shy Hat element 1. And they are really into about the shy hat element too. Okay, so if we were to print this all out, it would look something like this. Rich, because it has all the monies equals false. Thando says, weird syntax, but like, can we list 1 plus list 2 and their elements would be combined? Weird indeed. I've just arrived, what are we doing? So we're just practicing with a little Python. Hold on, so I think I've got... So we put in the F string, we've got our list. Did I misspell something? Oh, I misspelled it. Yeah. Okay. So you need to make sure everything's spelled correctly. Run the thing. No? Okay, I got it spelled incorrectly twice. Okay. Make sure that everything is spelled correctly. Okay, is this Python? Cybercoster, hello, nice to see you here. What is up? Yeah, we're doing a little lesson on working with Python right now. So this is the 3rd one in our series. I think they've got, yeah, pesky, I need to type the correct thing. Bugs, yeah, that's a common one. It's a common one. Okay, so we can also use list objects as part of f-strings. And originally we had a string formatting exercise that we did over at learnpython.org. I don't really like using that website very much, so we're going to skip that. And we're going to just do a little string formatting quiz. So we've got 2 questions about string formatting that we're going to answer here. Which of the following Python code is a valid method for printing variables and strings? So in this example, name equals HackerFrog. Do we do method A, print f hello name inside of the inside the curly braces, or do we do print hello plus name plus exclamation point? So which one of these will work? Or is it both, A and B? Okay, I think A, you can't add strings. Skyren Brook says, I think it's C. So the answer is both of these actually work. So if you do hello plus name plus exclamation point, this when you work with strings and operators, they also do like concatenation, and they also do like multiplication if you're looking for that. So we'll demonstrate over here. So if name is HackerFrogs, we do print hello plus name plus plus exclamation point, like this. This does work in Python. So hello HackerFrogs. Well, okay, we definitely need to put a space in there. There you go. Hello HackerFrogs. Okay, every programmer has forgotten in a semicolon or misspelled variable name at some point. That's almost certainly true. Okay, isn't it good practice to put colon? Sorry, comma instead of plus. Can we? Can we do that? I mean, would that work? Hello, and then name. Does this work? Yeah, it seems to work. But of course, this also introduces spaces into the thing. Because when we do the commas here, it automatically adds a space between these. So if we don't want the space, we really can't use this method. I mean, I'm pretty sure there are ways to get around this as well. Use a dash. Dash. Where do we put the dash? But yeah, I mean the more elegant way to do this would be to use the f strings. But the unfortunate thing about f strings is that they were introduced like in a more recent version of Python. I'm pretty sure they're available from like Python. I need to double check this. When were Python f strings introduced? Okay, Python f strings were introduced in Python 3.6. So I mean that's not very recent. December 2016. That's like over a decade ago. I guess we can pretty much assume that all modern versions of Python are going to have this feature. So let's see. Hello name. Like this. It's probably the better way to do it. Okay. Instead of the space, just use a modern. You mean like Python 2, right? I mean Python 2. Yeah, nobody uses Python 2. You do see Python 2 in the cybersecurity world because you do see scripts that were written like 20 years ago, and those are not going to be in Python 3 because Python 3 was not in use 20 years ago. So that is so you're still going to see Python 2 every once in a while. Okay, and so let's talk about basic string operations. So strings, actually, this could come in handy in the Advent of Code challenge we were doing earlier. So strings in Python are considered an object class, and classes in Python have special operations called methods that can be applied to those class objects. So for example, if we've got a variable called Seattle, Seattle is considered a string class, and as a string class it can use the count method to count the number of, well, e's inside of the string. It returns the number. In old versions, string.format was used. String.format in Python? In Python or in another language? Okay, so use of methods. I gotta clear my throat just a second. Okay, so Python 3.0 was released in December 2008. So that's almost not true anymore, Shy. Well, that's true. Cybernerdante says, go Seahawks. Hey, we're talking about Seattle, of course. You need a water break? My suspects? Yep. I think we should have a like a water break coming up pretty soon, I think. Anyways, use of methods in Python code can be identified by the name of the object. So city is the name of the object, followed by a dot, followed by the name of the method. So object dot method name, then parentheses, and any arguments that the method requires inside of the parentheses over here. So in this case, we've got all these things. So I mean, the most important thing that you can do when you're learning how to code is just to start experimenting with the code and trying out some of the things that you learn in the class. In fact, we can do this right now. So over here, we got name equals HackerFrogs, and then name dot count, and we'll count the number of R's. How many R's are in HackerFrogs? Okay, and then we'll print that out. It should return 2. Yeah, two R's in HackerFrogs. So anytime you see this stuff, in Python in particular, it's very easy to just start playing around with the code very, very quickly. Okay, uses of functions in Python code can be identified by the name of the function, followed by parentheses, and then any arguments the function requires inside of the parentheses. So functions and methods look kind of similar. The big difference between functions and methods is that methods are usually appended to the end of an object. So it's object dot method, but when you write a function, you usually just write the name of the function, and then you don't need to specifically use the dot. What is the word? The dot syntax. When it is an object and when is not. Yeah. So I mean, the method is connected to the class object. In this case, it's a string. But in this case, length. I mean, length is also something that doesn't necessarily work on all. Length is restricted to certain object classes as well, because you can't run length on like a boolean, but you can run it on like a list or a string. And a function is not on an object. So the method is attached to the object. Methods are attached to the objects, and functions are not. You can also, methods are usually accessed through a dot, and functions are not accessed through a dot. So note that in both functions and methods, inclusions of the parentheses are required, even if there are no arguments required for the function or method to execute. So anytime you run a method or a function, you need to include those parentheses, because if you don't include them, it's not going to run. So we're talking about, in this case, we're illustrating the length function, which can be used to return the number of characters in an object. So for a list, it lists out, it gives you the number of objects in the list, and in a string, it gives you the number of characters in the string. So if we go over to our example, we could do length of name, and it'll count out each one of these characters here. So how many characters is that? It's like 11 characters. So this should return 11 if we print it out. So run this, and we get the number 11. Cybercoster says, I don't mean to hijack the stream. Can we learn about encryptions and encoding? There's so many different ones in CyberChef. Yeah, I mean, we were talking about encryptions and, well, encoding stuff. We were talking about that earlier today, in like maybe an hour ago. But yeah. I'm late to the party. I'm looking forward to the next session and learning this. Nubian, hello, nice to see you here. In encryptions and encoding stuff, I think we talk about. I do like a cryptography course for like easy cryptography CTF challenges, and I think I do it like. I'll probably do it in like 2 or 3 courses after this one is over. Anyways, so print length of name, we get 11. If we were to give it in like a list instead, so my list, and we'll put some stuff in my list. Or actually, let's call this groceries. Grocery list. So the grocery list is going to be bread, and it's going to be milk, and it's going to be, I don't know, apples. So if we want to get the length of this list, it'll return how many items are in the list. So length of grocery list over here, and it returns 3. Okay, and yeah. So the length function. So the length function is used to count the number of indexes contained inside of an object. So when we refer to the elements inside of an iterable object, so like a list or like a string, I think the official term is the index. So each item inside the list is referred to by the index. So index 0, index 1, etc., etc. In the case of strings, it returns the number of characters, and in the case of list, it returns the number of items in the list. Okay, so the index method is used to locate the first instance of the argument within the object. So the output is the number of characters into the string where the object appears, counting from 0. So the one confusing thing about working with working with iterable objects like lists and strings is that when they start counting, sometimes they start counting from 0, and sometimes they, well, when they're talking about the index, they count from 0. And when they talk about the number of indexes in the object, they start counting from 1. But it can be a bit confusing to people who aren't aware of this. But anyways, we're talking about the index method in this case. So if we got food equals pizza, and we run food.index a, it'll find the first index where the a appears in this case. So this is 0, 1, 2, 3, 4. So the first a is at index 4, so it prints out index 4. So we can do it ourselves over here. Grocery list. Let's do grocery list.index. Grocery list index indexed milk. So we'll find where milk is inside the grocery list. So run the code and unmatched. Oh, did I have one too many parentheses. Okay, run it again. And it says index 1. So index 1 means 0, 1. This is where it appears in the list. Okay, here the output of the method is 4 because we start our count from 0. So it starts counting the indexes from 0, 1, 2, 3, 4, and this is what it returns. Okay, the next method we're going to be talking about is the count method, and the count method returns the number of times the argument appears in the object. Note that we don't count from 0 in this case because we're talking about numbers of instances, and we're not talking about the indexes, or we're not referring to the index by the position. So this is just something we need to get used to. So if we wanted to count these things, let's take a look at our example here. So grocery list, we're going to count the number of times that milk appears in the grocery list. This should return 1 because there's only one instance. Yeah, but if we added another instance of the string milk to this list, then it'll come back as 2. So we'll run it again. Now it returns 2. Okay, so we can also do string index slicing. So just as we can index lists to retrieve the item contained at a specific position, we can index strings with each character in the string counting as a separate item. So if we've got a string, so for example we got dog as the pet variable, and we print pet at index 0, then we get the letter D. So just like let me do a little demonstration over here. So inside of here we've got 2 items that we could iterate over and that we can refer to by index. So the first one is a string, and the second one is a list. We can refer to both of these variables by their index. So for example, if we print grocery list index 0, then it should return the string bread. So this is bread, but if we refer to name index 0, it should give us just the first letter in the name, HackerFrogs, which is the letter H. Okay, Henky Logwick says, good morning, love to learn from you with a cup of coffee. Hey, hope you're having a good cup of coffee and a good morning, Henky Lodwig. Thank you. Okay, and in fact, if we wanted to print out all of the characters one letter at a time, what we could do is we could do a little for loop. So for index in, well, actually, let's call this index. For index in name, we'll print the name, or we'll print the index. So if we were to run this, it'll print out HackerFrogs, one character at a time over here. And we can also do the same thing for grocery list. So for index in grocery list, print index, and that prints out bread and then milk and then apples and then milk, which is what we have in our list. So let's go back. So remember, when indexing in Python, counting starts from 0 instead of 1. What's more interesting is the ability to select specific slices of the string. And here we've isolated the third and fourth letters from the string Python. So when we reference indexes, we can also slice these. We can also slice up the strings. So we can slice up strings. We can also slice up lists if we wanted to. And in this case, what we're indicating here is 2:4. So 2 is where we begin, and 4 is where we end. And we separate these with the colon here. So if we start at index 2, remember this is 0, 1, 2, which is the letter T, and we stop before the number 4, the index 4. So this is 0, 1, 2, 3, 4, which is the letter O. That means we start here and we end before here. So we just get the letters TH. Okay, second of mine says we can also do range length of grocery list method if you want to refer to the indices, or use I, produce in enumerate grocery list. Yeah, I mean, sometimes we definitely combine a lot of these common functions with other code. So the length of something, the length of the string, or the length of the list, and we use it as part of our other code. Okay, so inside the brackets we indicate the character to start from, counting from 0, and then a colon, and then the character that marks the stopping point, which is not returned. So if we do start at index 2, stop before index 4, 0, 1, 2, start here, and we stop before index 4. I mean, I think I can, let me demonstrate this a little bit more clearly. Okay, so if we've got our string equals Python. So Python is a string, and the indexes are 0, 1, 2, 3, 4, 5. Let's make this a little bit bigger. So if we do string, and then we index it, we slice it by 2, 4. So what we're actually getting is we're starting at index 2 here, and then we stop before index 4. So one really confusing thing is that when we do our string slicing, the number on the end is not included, but the stuff before it is. So this returns just the T and the H. So this equals TH. Okay, please teach about Dart. Please teach about Dart. Dart? Are you talking about the programming language Dart? I mean, I don't know anything about Dart. I don't think I could teach you anything about Dart. But you know what? Go over to the education resources. So exclusive selection and not inclusive selection. Is that, I mean, I didn't go to school for computer science, so I don't know, I don't necessarily know these terms. But yeah, it is something you need to get used to when you're dealing with string slicing inside of Python. A lot of other programming languages do the same kind of thing. But Terrence, if you want to learn about Dart, go over to the education resources and then click on programming. You should see some good resources down at the bottom of the list. Inclusive means with the selector, exclusive means without the selector. Okay. So 2-4 indicates the start from the third character, because we're start counting from 0, and stop at the 5th character, not including it with the output. So another thing we can do with string slicing is we can include an extra colon when we do our string slicing. If a second colon is included in the index slicing, the number to the right of it indicates the number of characters you want to count by when slicing. So in this case, we've got the word bug. Well, sorry, the variable bug equals the string centipede. And if we slice up bug by 0, 9, and then 2, this means we start from the 0th index, which is the first character here. We stop before index 9, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which basically means the entire string. And we count by 2, which means we only include every second character after the first one. So we start here C, and then we skip to N, and then we skip to I, and then we skip to E, and then we skip to E. So the string, so SysOS says, Hanky Loudwood says, slicing is awesome, we can reverse the string with it. Yeah, we can. I think we'll talk about that in just a bit. So SysOS says, for the string ABCXD, does 0 colon 4 yield ABCX or ABC? So 0, 4? I mean, I'll answer your question, SysOS. Let me grab your message. Okay, so if we go over to here, so ABCX string slice 0, 4, like this. So let's talk about this. So let's number the indexes. So if we do something like this, then the 4th index is not returned. So the 4th index D does not return, but we start from 0. So we start from 0, A, B, C, X, and this is what we should get. You know what? Let's try this out. We can just go over to our coding window, and let's call this string. String equals ABCX, and we'll print it out. So print string 0, 4. So my guess is that we get these 4 characters here. Yeah, this is exactly what we get. Okay, miscounted. No worries. That happens all the time. Hold on. Let me see if I can change up the music. Let's make it a little louder. Okay. So, I mean, the most complicated thing that we're going to be dealing with today is string index slicing. It takes a little bit of time to get used to, but this is actually stuff that you do quite a bit when you do a lot of manipulation of strings inside of Python. So in this output, we see that the slice starts from the first character, ends before the 10th character, and then skips every second character. So we do 0, 9, 2. I find most of the time you're not really using this third character here unless you're counting backwards, which actually does happen. We'll talk about it in just a little bit. So the last part of the string index slicing that we're going to cover is using negative index numbers. So using negative index numbers is pretty common, and it's used to start from the end of the string or the end of the object as opposed to the start. Exclusive is running from element 0 up until element 4. Inclusive is running from element 0 after element 4. Yeah, I mean, I'm not too sure how you would specify specifically like inclusive for Python inside of the Python syntax. Okay, so the last part of the string index slicing we'll cover is using negative index numbers. If a negative index number is used, the index starts counting from the end of the string instead of the beginning of the string. So if you got fruit equals grapes and you refer to fruit and the -1 index, it gives you the letter S. So -1 in this case refers to the end of the string, the last object in the string. So S as opposed to G. You can't unless you're doing the looping yourself. I guess that's kind of the way Python works then. So here we're printing out the string index for grapes at the -1 position, which is the last letter. And we can do this for stuff that isn't strings as well. So if we go over to here and we do print grocery lists at -1. So grocery lists, and we reference the -1 element, it should come out as milk, the string milk here, because it starts counting from the end instead of the beginning. It goes right to left instead of left to right in its counting. Boscan says 0 to 4 exclusive is 0, 1, 2, 3. Inclusive, it's also 4. Thank you for that, Boscans. So when indexing, if we include a colon without a number to its left, the first colon will have a default value of 0, that is the start of the string. And the second colon will have a default value of the number of characters plus 1, that is the end of the string. So we got, if we have a string, if we have index slicing, but we don't include numbers to the left of these colons, it'll put in a default value. So here, the whole string is in range due to the inclusion of 2 colons with no numbers to the left of them. And we're stepping through the character in reverse order, 1 by 1. That is indicated by the -1 to the right of the second colon. So if we do that, we can actually run through the string or the list in reverse order. Let's demonstrate. So over here, we'll print out the grocery list, but we'll also give : and then -1. That means that the entire list is in range because of the default values, and then we run through them in opposite order. So it should be milk, apples, milk, bread that is printed out. So run the code. Milk, apples, milk, bread, which is the opposite order of over here. We can also do this with our strings to print them out backwards. So instead of grocery list, we'll do name, and then run that, and then we get HackerFrogs. HackerFrogs backwards, so it's Sigur Frekak. Sigur Freka. Sigur Freka. Alright. Okay, we also have a few different methods that we can do with our strings to make sure that they are output in specific formats. So the upper and lower methods. So the upper and lower methods output all of the characters in uppercase or lowercase respectively. So this can be useful if you want to make sure that all of the characters in a string are the same case. You can either output them all uppercase or lowercase. So we can do that over here. So we'll output name dot upper, and this should print out HackerFrogs but all uppercase. And we can also do lowercase. Okay, And yeah, so this is a great way to format your strings. Does it work on tuples? Does it work on tuples? Does it work on tuples? You mean string indexing for tuples? I could give it a try. Grocery tuple. So the tuple is going to be bread and milk and apples. And then we'll do grocery tuple index -1. Let's see if it works. Yep, still works. So tuples in this case can be sliced up just like lists and just like strings. You're so kind. Thank you very much, Cybercoster. I'm glad you think so. I try to be as nice as I can be, given the circumstances. Anyways, upper and lower methods, starts with and ends with methods. So these are methods used to test whether strings contain the specified argument at the start or the end of the string, respectively. So starts with and ends with are both going to return either true or false, which are some Boolean values we're going to be talking about later. Maybe I think we're going to be talking about that in the next workshop. But if we do the test dot starts with or dot ends with, it'll either give us a true or false as a result. Okay, so we can test this. So it starts with ends with in our code. So let's get rid of our grocery tuple. So we're going to print grocery tuple dot starts with. Does it start with milk? So we're checking whether or not the grocery, oh, it's not the tuple, we're looking for the list. We're checking the grocery list, and we're checking to see if the first object in the list is milk. So this will return true or false, and we see that it returns list has no attribute starts with. Okay, so we can't do this with lists. We can only do this with strings. Okay, so let's do name. Name dot starts with. Does it start with frog? Okay, thank you very much for subscribing on YouTube, Philip Nedelkowski. Thank you. Okay, so we'll run this. So starts with is, well, I just learned that starts with is exclusive to strings. You can't run starts with lists, unfortunately. Okay, so this comes back false. So name dot starts with frogs. It does not start with frogs, but we can check it again to see if it starts with the word hacker or hack. Okay, check this. It comes back true. So we can also do the same thing with ends with to check if the string ends with a certain string or not. So does it end with hack? Name, does it end with hack? False. Does it end with GS? Does it end with these letters GS? Now it's true, because it does. Okay. So we also have the split method. So the split method is going to convert a string into a list with the separation between items indicated by the argument given. Usually it's going to be a space or a comma. So the split method is actually something we use a lot in Python. If you want to take a string or like a long string and you want to separate out the elements, we use the split method. So in this example here, we've got groceries is a string, and it's eggs, milk, bread, and lettuce. But if we wanted to separate these and turn into a list instead, we would make a new variable, groceries list, and this would be the result of groceries.split on the comma. And in this case, if we print it out, then we get eggs, milk, bread and lettuce, and we see that it's been separated out into a list. I mean, we can do this ourselves. Let's give it a try. So if we've got our grocery list, actually, if we've got our name here, and the name is equal to HackerFrogs, if we wanted to split this up into a list, we would call this list something like, I don't know, letters in, we'll call this the letter list. And the letter list is going to be name.split. And if we run name.split without any arguments, it's actually going to split by each index. So H is going to be in there and it's going to be separated, A is going to be separated. And if we do this, and then we print out the letter list, then we're going to see a list with all of the letters in the word HackerFrogs. So we do that. Oh, it didn't split it by, it didn't split it. I guess in this case, I mean, we could also take the string HackerFrogs and we could split it up like this. And if we had this, then we would split it up by the space, like this. And then it would create like a bunch of letters, like this. Try splitting for Fried Popcorn. Hello, nice to see you here. And Harness IQ. Hello, nice to see you here as well. Try splitting for empty string. Yeah, I mean, we could give that a try as well. So it works if we split up the string by spaces. But if we split by nothing, let's see if it works. Ah, okay. So it says empty separator. So we have to specify a character to separate by in this case. We can't just run it through. Okay, I mean, split doesn't work in that way, that's fine. I think we can also split up. I don't think we can do split on lists. It has to be on strings, I'm pretty sure. Anyways, we'll continue. Okay, basic string operations exercise. We're just going to skip that one because it's not very fun. We'll move on to the quiz. So what is the output if we use the following code? If we do print HackerFrogs, so HackerFrogs is the object that's being sliced. If we do 6:-1, what is going to be output if we print this out? So is it going to be A, frogs, B, R, capital F, R-O, or C, frog, or nothing will print, the syntax is incorrect. So it's going to be one of these. Okay, put in your answers now. So 6:-1. So remember that the first number is the place where it starts. After the colon is the place where it stops. So index 6 is the 7th character. 0, 1, 2, 3, 4, 5, 6. So it starts at the capital F, and it stops at the -1 index, which is the end. So SysOS says D, and Fried Popcorn says C. Okay, so the answer is C, frog. So it stops before -1. So -1 is the S, it stops before that. So I mean, we can give this a try. So grab this code and then go over to here and run it. Oh, empty separator. Okay, run it again. frog. So you can actually supply this directly. So any string, you can see you can split it like this, and it comes out as frog. So it starts at index 7. Sorry, object 7, 1, 2, 3, 4, 5, 6, 7, and it stops before -1, which is the last character. So it just puts out this. Okay. Next. Let's see. Okay, so we're just going to do a little review exercise here. We're going to write a program which records your full name, first and last, then tells you what your last name is, and how many letters are contained in it. So, I mean, originally I had people just, take a little bit of time to write the program, but we don't have that much time to work with. The social engineering hack worked, of course. So what we're going to do is we're going to go over to our end of session exercise code. You can find it over here. And we're just going to talk about how this program works. So just go down to the end of session exercise code and copy it. Thank you very much, Fried Popcorn 5, for subscribing with Prime. Thank you. And if you want to know how to do that yourself, here's the Prime information. Thank you very much, Fried Popcorn. Let's give you a fun little message. Sorry, video redeem. How about some Jurassic Park?
It's a Unix system. I know this. It's all the files of the whole park. It tells you everything.
Did you know that they used Unix to protect themselves from dinosaurs in Jurassic Park? Well, now you know. Okay, so we'll go back to the code window here. And thank you very much again, Fried Popcorn, for the subscription with Prime. Okay, so what's going on in the code here? So full name equals input. What is your full name? Remember that the input function, it takes in user input, and it saves to a variable here if you supply the name of a variable. So whatever you type in as your input is going to be interpreted as the full name variable. And then we're going to define split name, and split name is going to be full name.split. Remember that if you give split without a separator, it'll separate on spaces. So if you give it like a name like John Adams, it'll create a list with one item called John and the other item called Adams. So the last name is going to be the split name in the index 1. So index 1, of course, is the second item in the list, not the first one, which is a bit confusing. And the last name length is going to be defined as the length of the last name variable. So last name is equal to split up last name, so the second name in the name list. And we're going to print out a little message. Your last name is last name with our F strings, and then print there are last name length letters in your last name. So I mean, if we run this code, it doesn't really work unless we're dealing with exactly two words in our name. So for example, Adam Smith or John Wayne. So if we run the program, it'll ask what is your full name, and we'll supply John Wayne. Okay, and then we get your last name is Wayne. There are 5 letters in your last name. So I mean, it's not a super complicated program. It definitely doesn't work in all cases, but it is simple enough to understand. If there's anything you don't quite understand about how this program works, let us know, and we'll try to address your issues. So the other thing we could do is we could start messing around with this program a little bit more. So we could create like a first name variable, and that's going to be equal to split name element 0. And we could print out something like print f string your first name is first name. And if we run that, it'll ask us again, what is your full name? How about our name is David Johnson. Okay, your first. I gotta correct my typos. Let's do that again with David Johnson. Okay, your first name is David, your last name is Johnson. There are 7 letters in your last name. Okay, great. Fried Popcorn says you can set last name equals to split name -1, so you always get last name. Oh, you know, that's a good point. So if you do last name equals split name -1, this always refers to the last thing. So if we write it like this and we give 3 names for some reason, then it'll always get the correct last name. So I mean, we could try running this, and we do my name is John David Adams, and then your first name is Adams. Oh, sorry, I did the wrong one. So first name first name should be name split. Yeah, so okay, we'll do it like this. We'll do it one more time. All these errors. John David Adams. Okay, so your first name is John, your last name is Adams. There are 5 letters in your last name. Okay, this works out. Great. And I think we'll do a little review before we finish out today's class. So let's review the programming concepts we learned in this workshop. So we learned about string formatting. String formatting is a way for us to include variable names, variable values in strings by using f strings. So we can use the f strings, we can include in our print format, in our print function, the names of variables, like name or daily coffee. We just need to make sure that we got the letter F in front of our string. We talked about basic string operations, and strings in Python have a number of different functions and methods that can be useful for obtaining specific details about these strings. We can also output slices of strings through string indexing. One thing that's really interesting about string indexing, or a lot of these string methods, is that a lot of string methods also work on lists, because both lists and strings in Python are iterable container objects. So much more so lists than strings, of course, but yeah, a lot of the same tricks work. We can also output slices of strings through string indexing. And in the next HackerFrogs AfterSchool programming workshop, we'll continue learning Python with the learnpython.org website. Of course, I don't really use that website anymore, but in our next workshop, we're going to be talking about loops and functions. So loops and functions are both very, very common things we see inside of all our programs, and we're going to be figuring out what these loops are, how to write them, and how to write functions as well. Okay, so everybody, we're going to be doing that lesson on Monday. So today is Friday, and we're going to be doing it on Monday as part of week 12. So that's going to be on March 18th. We're doing HackerFrogs Python Basic Session 4, and we're also going to do Session 5 on Friday, so please look out for that. All right, so let's go ahead and move on into the next topic. So I've got 60 minutes on the clock, and topic 3 is done. Topic 4 is here. Topic 5 is on deck. Skyron Brook says, thank you very much for these interesting exercises. Thank you, Skyron Brook, for being here. I appreciate everybody in the chat, even if you're not talking. I appreciate everybody being here. Okay, let's move on to the next topic. Sorry, so this is week 11. Our topic is file upload attacks. Okay, so we're going to be going over to HackSmarter. So HackSmarter is also known as Tyler Ramsby. He's a person who does cybersecurity education content and also has a cybersecurity education platform. Tyler Ramsey is a really great member of the online cybersecurity community, and you can find him over at these links over here. So where is HackSmarter? So HackSmarter is a YouTube channel as well as a Twitch channel. So I'll leave his links in the chat. So for Twitch it is over here. For YouTube it is over here. And what we're going to be doing today is we're going to be doing one of the modules from his education platform, HackSmarter. So this one is called File Upload Attacks, and we're going to be learning about how we can upload malicious files to insecure websites. And if you want to join along with us, this is the link for the module over here. So the module that we're doing today is free because I like to showcase free content because not everybody has a bunch of money when they're learning cybersecurity. I'm not saying that you shouldn't pay money for stuff when you're learning cybersecurity. What I'm trying to say is that a lot of people are there, you know, they might not necessarily know if they want to get into cybersecurity or not, so they shouldn't have to pay a bunch of money to be able to figure that out. And that's why I cover a lot of free stuff. Okay, so file upload attacks, we can enroll into this module here by clicking on this button. Did that go through? Okay, so we're in. I guess what we can do is we can read up a little bit about what's going on here. So this is a guided walkthrough. It's not necessarily a challenge module. So we can read up a little bit about file upload attacks, and then we will get into the lab. Okay, so golden rule and impact. So I guess this is part of the introduction. Okay. So file upload functionality is ubiquitous. Modern web applications fundamentally rely on it. Users need to upload profile pictures, job applicants need to submit PDF resumes, patients upload medical records, and employees share financial documents. However, because this feature serves as a direct physical gateway for external, untrusted data to be written to a server's file system, it represents one of the most massive and historically exploited attack surfaces in cybersecurity. So the golden rule is never trust user input. Whenever a user is allowed to upload a file, they are crossing a critical trust boundary. The absolute golden rule of file uploads is that the application must treat every single uploaded file as highly radioactive. If a developer fails to properly sanitize the user's input, validate the file's true contents, and strictly control how and where this file is stored, the impact scales rapidly from localized application errors to devastating network-wide compromises. SysOS Master says never trust any input, user or not. And Dev R8X5Q, Super Chat $5 Australian. Hey, thank you very much. Have you ever done any data security tutorials, like MS Purview, for example? And yeah, thank you very much for the Super Chat, Dev R8, thank you. And have I done any data security tutorials? Data security tutorials? I mean, I've done a lot of tutorials and a lot of demonstrations on this channel. MS Purview, I'm not really familiar with that particular application, but I have done quite a number of like file upload attack examples on my YouTube channel. Let me give you a little list. So I mean, if we were taking a look at file upload attacks in particular, I could search up upload in my video list. So yeah, so we got Vulnix exec, Samba file upload attacks, sudo apt hacking, and we've got over-the-wire challenges here, and we've got a bunch of them in web app hacking as well. So file upload attack, no sanity. I can give you the list, but we do a lot of demos. We do a lot of tutorials here as well. But if there's something specific, I mean, I don't know about MS Purview, if you're looking specifically for that. Thank you very much for following Smaddy Sun. Thank you. Let's go back. Okay, so the next section, what happens when uploads go wrong? When malicious files bypass filters, attackers can leverage them to execute a variety of attacks. Here's a detailed look at the threat landscape. Okay, so we got number 1, remote code execution, otherwise known as RCE. This is the holy grail. This is the most critical threat. Web servers, like Apache, Nginx, and IIS, are designed to execute specific file types, for example, PHP, JSP, Python, or ASPX. The attack. If an attacker can upload a web shell, that is a malicious script, and use their browser to navigate to the directory where the file is stored, for example, vulnerable site.com uploads shell.php, the server will execute the attacker's code instead of just displaying it. Yazan Chi, hello, nice to see you here. Thank you very much for coming by on YouTube chat. Thank you. Okay, so the impact of this is the attacker gains a command line shell on the underlying operating system. They can read database passwords, steal customer data, pivot to internal networks, or install ransomware. So number 2 is path traversal and file overwriting. So attackers don't just control the file contents, they control the metadata sent in the HTTP request, including the file name parameter. The attack. An attacker intercepts the upload request and changes the file name to something like var www.html index.php or etc cron d malicious task. So the impact of this is if the server doesn't strip out the directory traversal characters, it will save the file completely outside of the intended /uploads folder. So this means that people could potentially upload files into other sensitive parts of the web server, which would be very, very bad. Okay, Yuzanchi says, I feel like it's hard to find file inclusion in the website that easily. I mean, it exists where it exists, usually as a result of people messing around with not sanitizing properly on user input. So it's usually people trusting user input, which is a really, really bad thing, and not doing input validation. That usually leads to file upload attacks like this. Okay, so the third impact could be cross-site scripting and privilege escalation. So not all file uploads are designed to attack the server. Many are designed to attack other users or administrators. So in this case, the attack would be an application might successfully block PHP files but allow image uploads. So an attacker can upload a SVG image, so for example avatar.svg. Because SVGs are XML based, they can natively contain script tags. So Zancy says, let's see, do you think Python scripts are good? Do you think Python scripts are good? Because I feel that there isn't a tool for that. I'm not too sure what you mean in this case. Do you think Python scripts are good? Because I feel like there isn't a tool for that. Can you reword your question? Because I'm not really too sure. File inclusion. So file inclusion Python scripts or something else? SysOS says, I found that such things in medical websites, things that hold patient data, never assume stupidity is not present. So file upload Python scripts. I mean, there are a lot of different tools that people use to scan for various web vulnerabilities. Most of the time most professionals use something like Burp Suite Scanner. Let's talk about this. So portswigger.net, they're the people that create Burp Suite, which is the most popular web app security tool. So Burp Suite contains a tool called the Burp Suite Scanner, and the Burp Suite Scanner basically takes whatever website that you feed into it, and it performs a bunch of tests on all the endpoints that it can find. Most of the time, if there is some sort of low-hanging fruit file upload vulnerability, it will be able to identify this kind of thing. The other thing you could do is you could do manual testing. Of course, you can, if you wanted to, you could write up like a Python script that can scan for whether or not there is a potential file upload vulnerability associated there. Anyways, let's go back. Okay, Python, sorry, SysOS says Python files are evil because you can spawn fork bombs with it. Smatty-san says, sorry, if I should trust no user inputs, how can I safely download a shared Word or Excel file from Google Drive or a coworker? So trust no user inputs. How can I safely download a shared Word or Excel file from Google Drive or a coworker? I mean, the thing about Google Drive we should understand is that Google Drive itself also runs also does like virus scanning on whatever is uploaded to Google Drive. So it would be kind of difficult to upload malware to Google Drive, because when you upload stuff to the Google Drive, it also scans to see if there's any malware inside. Usually stuff from Google Drive is a little bit more safe. How do you safely share files? I mean, it's up to trust. We're not really talking about the web application itself at that point. Yazanji says, do you think Portswigger is enough for learning websites? Because I feel like there's it's helpful more than Hack the Box and TryHackMe. I mean, Portswigger is the gold standard for learning web app security. If you go to Portswigger and you already know like stuff about web app development, the Web App Security Academy here is a very, very good resource for learning about web app security. I would say if you were to choose one website to learn from for web app security, it's going to be the Portswigger one. Okay, and SysOS Master says, but treating it as radioactive, wrap it, stamp it, log it, and test it. You just need to be more careful than you would normally. VirusTotal can help, yeah, absolutely. So if you ever suspect that a file might be malware or might be suspicious, you can go over to virustotal.com and upload it to the endpoint over here. And it'll be able to tell you whether or not this particular file is associated with malware. Okay, Too Legit One says, I personally prefer Python, PHP, or Node.js for scripting. I mean, whatever works for you, yeah. Okay, so let's see. It also does unwanted content scanning, like looking for CSAM, which has resulted in lost data like patient photos. Oh, that makes sense. It makes sense that if there are sensitive photos of like underage people that are used for medical treatments, then it would count that as CSAM. So that's kind of a weird side effect. Anyways, let's go back and talk more about this. Okay, so script tags. When an administrator logs into the backend panel and views the user's profile picture, the attacker's JavaScript executes in the admin's browser. This stored XSS payload could instantly steal the admin session cookie, allowing the attacker to hijack the account and escalate their privileges. This isn't something I have seen too much in CTF exercises, although it does seem like it does seem completely legitimate, of course. Okay, number 4, malware hosting and phishing. Sometimes the attacker just wants to use your server's good reputation. The attack. An attacker uploads an index.html file designed to look exactly like a Office 365 or Google login page. The impact. They can now send phishing emails to victims with the link yourtrustedcompany.com/uploads index.html. Because the domain is legitimate and has a valid SSL certificate, it can easily bypass email, spam filters, and trick users into handling handing over their credentials. This is interesting. So people will use their malicious web pages and host them on a legitimate web page's website through a file upload function. So that's pretty devious, yeah. And we also have denial of service, DOS, and resource exhaustion. If an application does not strictly enforce file size limits and decompression rules, the server's resources can be weaponized against it. So for an example, an attacker writes a script to upload thousands of 5 GB dummy files. Alternatively, they use a zip bomb or a decompression bomb that is a tiny 42 kilobyte zip file that, when unzipped by the server, expands into petabytes of junk data. The impact in this case is that the server's hard drive fills up completely, causing the operating system to crash, databases to corrupt, and the entire application to go offline. So this is, yeah, you can use file upload as a vector for DOS attacks. Are you aware of the latest CVE of Notepad? That was insane. Notepad? I don't think I've heard that one. I've heard that there are quite a few vulnerabilities with Notepad already. But yeah, Cybercoster, if you could provide like a link to the news story, maybe we can take a look at it later. Zancy says, I wonder how DDoS works with Python scripts, because isn't the website blocking you if you send too much? I mean, we need to. This would happen after the file is already on the server. Not necessarily. Well, I mean, you could also, if you could get the website to run code, like arbitrary code, then you could use the arbitrary code to write files. In that case, to create or to completely exhaust the hard drive space or the storage space on the web servers, right? Okay, so summary of impact matrix. So you got remote code execution, path traversal, stored XSS, malware hosting, and denial of service. What is the golden rule when it comes to handling file uploads from a user? Treat it as radioactive. Radioactive? Submit? No? Okay, let's go back to up to the golden rule, and we'll never trust user input. Okay? Okay, Yazanji says, can you explain DDoS and DOS? Because I feel it's confusing. So DDoS and DOS are both denial of service attacks. One is a distributed denial of service. So DDoS is distributed denial of service, and the regular one is just denial of service. So DDoS means that you're using multiple machines to attack the service. I mean, I guess I could talk about it over here. DDoS is distributed denial of service versus DOS, which is just denial of service. So the difference is DDoS uses multiple machines to attack the service. So usually when we think of DDoS, we think of using a lot of machines to send requests to the server. Treat as radioactive is generic file uploads. But I mean, they're both trying to shut down the service or shut down the server through some method. So that's what denial of service is. I mean, I don't really think too much about denial of service because it's not really something that's covered in most of the exercises that I do, because Denial of service, of course, is a big inconvenience, but it's much more nefarious to be able to break into a server than just to shut it down. Yazanji says, not a virtual one, right? It's more like one PC. Yeah, I mean, DOS, denial of service isn't really a CTF thing. Although I guess you could do CTFs that that test like denial of service methods. It's not really something I see too much of. But anyways, let's not get too far away from what we're talking about. What type of vulnerability is achieved by uploading a multi-gigabyte file to exhaust disk space? So this is a denial of service. Okay, that's correct. Which attack vector is considered the holy grail of exploitation, allowing an attacker to execute scripts like PHP or ASPX on the server? Overload and auth endpoint, maybe? I mean, yeah, I think so. You could probably set it up so that you could test like DOS techniques. It's just that, yeah, I don't see very much of it. So the holy grail of execution of exploitation is remote code execution, which lets you run arbitrary code on the web server or the application. Okay, which XML-based file type can be weaponized to deliver in a stored XSS payload, even if the application blocks standard executable extensions? So we saw this was the SVG file extension. Okay, complete and continue. Cybercoster says CVE 2026, it allowed Notepad to execute scripts. I mean, I can grab that CVE and just do a very quick search. So 0-day initiative, arbitrary code execution in Microsoft Windows Notepad. You can give everybody the link here if you want to take a look yourself. Okay, so what are we dealing with here? So file upload attacks in the real world. Non-null file upload attacks are aimed at executing code on the server. Often the goal is to target the administrators who manage the application. This case study highlights an exploit discovered by Tyler Ramsby in Ghost CMS. So, HacksMarter himself found this this exploit in Ghost CMS. Okay, a massive content management system used by major organizations worldwide. Okay, the setup. Ghost CMS allows users to upload profile pictures. The developers implemented filters to ensure that users can only upload image formats, preventing standard .php or JS web shells from being uploaded to their server. So the flaw, in this case, is the application allowed the upload of SVG. Oh, okay. So SVG files, unlike JPEGs or PNGs, which are made up of binary pixel data, SVGs are built using XML, text-based markup. Because they render in the browser, SVGs natively support embedded script tags so that the developer can create animated images. So the attack chain is the payload. The attacker creates a standard SVG file, but embeds a malicious JavaScript payload inside a script tag within the XML structure. SysOS says major system organizations, I'm 30 years in the future when the AI overlords have taken over. Major system organizations. Yeah, I misspoke there. Major what? Major organizations overwide. Major organizations worldwide. Anyways, okay, so the attacker uploads their malicious SVG as their profile picture. The server's validation checks if it is a valid SVG image. If so, the server accepts it and stores it. So the trap is the attacker waits for a highly privileged user, like a site administrator, to view their user profile or moderate their account. The execution. When the administrator opens the page, their browser loads and renders the SVG profile picture. As it renders, the embedded JavaScript executes entirely within the context of the administrator's authenticated session. The escalation. The JavaScript silently makes API requests on the behalf of the admin, upgrading the attacker's account to full administrator privileges or stealing the admin's session token. Okay, you can read all about HacKSmarter's full technical breakdown of the vulnerability, and I'll leave the link in the chat if you want to take a look. So the takeaway, accepting SVGs without heavily sanitizing the XML content is essentially inviting stored cross-site scripting into your application. So I mean the thing is that until this kind of technique becomes popular to the point where people talk about it, you'll never see people defending against this, because they wouldn't try to mitigate an attack that they don't know about. Okay, so the questions are: what CMS was vulnerable to an SVG-based XSS attack via the profile picture upload? What CMS? It was like Ghost CMS? No? What was it called? Ghost CMS with the space. Okay. Okay, it's already quite common to use by APT level attackers so state level. Okay, so hackers from hostile governments. So what is the CVE Tyler got via the file upload attack on Ghost CMS? Okay, so we'll just grab that CVE. Submit that. Or friendly. I was just talking about this with some people I was doing a presentation for. So a lot of people don't know that every government is hiring hackers to hack every other government on the planet. It doesn't matter if the government that they're hacking into is a friendly government or not. So American hackers working for the American government, they hack into the computer networks of friendly European countries, not because they're hostile, it's just because they want to get that access. Anyways, complete and continue. The amount of effort they put into it is the only difference. So I guess they would be a lot more interested in hacking into enemy country computer networks more than friendly ones, because they it's all about likelihood. How likely is the country to attack you, and how important is it to that? Anyways, I don't want to stray too far into something that could turn into politics, but anyways, that's every country tries to hack into every other country is what we're trying to say. Okay, so to connect to the lab, launch the machine, click on the Systems tab, download the VPN config. Okay, great. Connect from your Linux VM with sudo openvpn, blah blah blah. Okay, so we'll launch. Skyrim says organizations that use Ghost CMS include Apple, OpenAI, Cloudflare, Mozilla, Airtable, NASA, DuckDuckGo. I mean, I'm sure Ghost CMS was made aware, and they've probably patched their systems, right? There's no way that they wouldn't have. Okay, click on Systems, and we need to download the VPN config. So I'm just going to do that. Okay, so after we do that, we're going to start our VPN access. So here we've downloaded guided lab file upload. And we'll just copy that to our VPN keys directory. So I keep all of my VPN keys in the same directory here, so that we can, so that I know where to look for them. Anyways, we're gonna connect. Which one do we want? Upload. Hex Psycho has raided with a party of 2. Thank you very much, Hex Psycho. What were you up to? Welcome in, raiders. we're just doing a guided walkthrough for some file upload attacks over here. Sudo openvpn, this thing. And what were you getting up to on your stream, HexPsycho? Let's give HexPsycho a shout out, just a second. Shout out, HexPsycho. Here you go. Yeah, I mean, if any organization is using Ghost CMS and they didn't patch after it was discovered that there are, you know, big flaws in their CMS software, it's kind of their fault. Okay, so we should be connected to the private network because we've got the ton0 interface now. So just to make sure that we can actually access the server, we should probably try to ping it. So we're just going to copy the IP address and ping the thing. Okay, we've got a response, so we've got access to the server. Having it guy doesn't mean CSEC guy. Oh, who are we talking about? Thank you very much for following on Twitch, Adrian. Adrian? I'm assuming that's the name. Thank you. Okay, so I mean, I guess the first thing we can do is we can do a little nmap scan on this server. So we'll nmap this thing. Okay, so we'll run our nmap scan here. We got port 22 and we've got port 80, so this is pretty standard for your CTF exercise. Riyadh Gamer, hello, nice to see you here. What is up? What is up? What is up? We're just doing this module over here from HacksMarter. So this one's free. So if you want to do this thing yourself, you can. Okay, so the undeniable golden rule of web application server is never trust the client. In modern web development, it's a standard practice to implement validation at the presentation layer, that is the user's browser. Developers do this for two excellent reasons. Enhanced user-land user experience. Users get instant feedback if they make a mistake, forgetting to type in an email address without having to wait for the page reload. Saving server resources, it prevents the server from wasting processing power and bandwidth on malformed requests. However, a critical misunderstanding occurs when the developers confuse this UX feature with a security boundary. Because the application happens validation entirely within an environment the user controls, that is their browser, a malicious actor can simply manipulate, bypass, or entirely ignore these rules. So if security relies solely on the browser, it provides exactly zero security. Let's repeat that. If security relies solely on the browser, it provides exactly zero security, okay? Typical client-side controls. So client-side restrictions typically fall into two categories. So HTML attributes. HTML5 introduced several native attributes designed to restrict user input natively within the browser without requiring extra code. Except restricts file upload types, for example, except JPEG or PNG. Max length limits the number of characters typed into the text box. Disabled read-only grays out an input field, preventing the user from interacting with it. I mean, server-side, well, client-side stuff like this can be manipulated very easily. So type enforces specific formats. Type email or type number. Hidden fields storing values in input type hidden under the assumption that users won't see or change them. Number 2 is JavaScript validation. Custom scripts that run when a user attempts to submit a form or interact with an element. File extension checks. A script splits the uploaded file name at the dot and checks if the extension matches an allowed list. And regex matching. Scripts that ensure passwords contain special characters or that an input contains no SQL injection payloads like single quote or double dash. It's the first layer of defense, not the only one. Yeah, I mean, everything in security has to be, what is the word? Defense in depth. So it's a bunch of different layers that help defend your application or whatever it is. BRJC, hey, hello, nice to see you here. Thank you for the follow on Twitch. How to identify client-side controls. So before you can bypass a filter, you need to confirm it's happening on the client side. The easy way to tell is to observe the network traffic. Open your browser's developer tools and navigate to the network tab. Attempt to trigger the restriction, upload shell.php, when only images are allowed. If you're instantly met with an error message or pop-up, look at the Networks tab. If no HTTP post request was sent to the server, the validation happened entirely in your browser. You're looking at a client-side filter. Okay, so if you see the error pop-up here, but nothing was sent over the Network tab, then yeah, that's how you can tell you're dealing with the client-side filter and not a server-side one. Okay, 2 ways to bypass client-side controls. Once you've identified the control, there are several ways to circumvent it, ranging from simple browser tweaks to professional interception. We'll introduce 2 of them, okay? Disabling JavaScript. If the restriction is enforced purely by a JavaScript function, so for example, in onSubmit event listener, you can simply turn the engine off. So open DevTools and open the command palette. Type disable JavaScript and hit enter. The result is the browser will no longer execute the validation script. When you click submit, the form and your payload will be sent directly to the server. Okay? Number 2, use an intercepting proxy. Sometimes modern web apps, like single-page applications built on React or Angular, break completely if you disable JavaScript or manually alter the DOM, or the document object, what does the M stand for again? But anyways, in these cases, you play by the browser's rules, but intercept the traffic after a model. Yeah, document object model. But intercepts the traffic after it leaves your browser, but before it hits the server. So number 1, upload a valid file, but intercept the request. Number 2, replace the file with your malicious code. Number 3, forward the request. Okay, in the challenge lab, connect to the target, select level 1 security via JavaScript check, upload a PHP shell, and get full code execution. Okay, I guess we'll try answering these questions before we actually do the challenge lab. It looks like you start the level 1 on the HacksMarter lab. Yeah. Let's go back. So here we've got 2 file upload workshop. So I guess we can just navigate directly to this. So we're going to grab the IP address and then we'll navigate manually over here. Okay, so file upload workshop. Your goal, upload a PHP shell, shell.php, and execute code. So level 1, security via JavaScript check, level 2, content type check, and level 3, magic byte check. So these are 3 different methods we're going to have to circumvent. Andrew says, you think if I go door to door selling my malware? Selling the malware as a wrap CD? Do I have to learn how to wrap first? I don't think you need to learn how to wrap to spread malware via your wrap CDs. But hey, Andrew, hey, nice to see you here. What is up? Okay. MXT Freedom says, do you know that AI is helping in pen testing like Claude AI? Do you know that AI is helping in pen testing? I mean, a lot of people are using AI models to do pen testing stuff. Yeah, I've heard a lot of stories about this, but I mean, I'm not really covering that stuff right now. Maybe in the future when it becomes much more easy to set up. Didn't Sony already beat you to this? Are you talking about the rap CDs? Maybe. Okay, level 1. Let's check on that. Click on that. Upload a photo. Client-side security is the best security, right? Okay, so we've got nothing. So I guess we're talking about uploading like malicious PHP files. They'll probably teach us how to do it, so we might as well go back to the guided lab. What is the golden rule of web app security? Never trust user input. Is that it? Yeah, okay. You notice an error message appears instantly when you try to upload a file, but your browser's network tab shows that no HTTP request was sent to the server. What type of control is being enforced? So this is a clear message that a client-side restriction is being enforced. No. What type of control? So, I mean, this client-side control? Okay, they were looking for the word control. Okay, so it says the selling of malware is a wrap CD with a few different CDs utilizing a rootkit. Sony? Did Sony? Wait, that sounds. Why would Sony do that? They're not really in the business of, like, you know, of ransomware or like malware or anything like that, are they? Okay, so which HTML5 attribute is commonly used to restrict the file types a user can select in a file upload? Dialog. So it's like, which one was it? Accept. Okay. Sony BMG copy protection rootkit scandal. That seems like a. You know, the funny thing is that this kind of stuff hasn't really been covered on any of the podcasts that I listen to. This would make for a really good Darknet Diaries episode, wouldn't it? Actually, let me see if it's appeared before. So Sony BMG Darknet Diaries. Maybe it's. Yeah, I don't know if they've covered this on Darknet Diaries before, but let's continue. Here, okay. I was able to get full RCE. Yes or no? I mean, we should probably do this ourselves. Okay, so what we're going to do is we're just going to create a malicious script that we're going to try to upload. Let's put this in its own directory. We'll call this HacKSmarter upload. Okay, and we'll write out a script. The like a web shell for PHP doesn't have to be very big. I can probably look one up over at revshells.com. Okay, it's just older news like the Microsoft Embrace, Extend, Extinguish policy. MXTR Freedom says if you have set up an MCP server in your OS, Claude AI will use US tools like Metasploit, Nmap, and do pen tests, even create reports. I mean, if it's completely automated like that, that seems pretty cool. But the thing is that, I mean, how much money does it cost to run these kind of servers? Anyways, we're looking for the PHP command small, And this can be used as a very, very small web shell. So we're just going to create something called, we'll call it webshell.php. So the only thing we've got inside of our PHP code is this. So what this is going to do is it's going to return whatever's in the GET request with this particular URL parameter, and it's going to run this as a command, as a system command. Like $50 an hour for all the tokens. I mean, I would try that out myself if I had a lot of money, but I don't have so much money to use on like AI experiments. Okay, save this out. HexPsycho says, depending on your setup, you can run smaller models locally using LM Studio. I really need to, if I had like an extra like powerful machine available to me, I'd definitely give that a try. Okay, so webshell.php, we're just going to try to upload this. It's probably not going to work because, you know, where are we? Here. Okay, browse, and then other locations, computer. It's in my temp directory, HackSmarter upload, and we're just going to select all files, webshell.php, click on upload, and it says security alert, only JPEG or PNG files are allowed. Okay, Snollygoster says, you surely have enough money to learn Vim, though. I mean, I probably do have enough money to learn Vim, because you don't need any money to learn Vim. Okay, so they're talking specifically in this example about whether or not a filter is client-side or server-side. So in this case, we do F12, we look at the network tab, and we'll reload the page. Okay, so we get level1.php and favicon. So if we try to upload this, and we see the error message pop up, and we don't see a new network connection, that means that the controls are on the client side. And thank you very much for following on Twitch. Subloon0, thank you. Okay, you need the time to learn Vim or to ask your... I mean, I'm not opposed. I'm not opposed to learning Vim. We'll make it like a sub goal or like a donation goal or something. That would be great. Click on upload. Security alert, only JPEG or PNG files are allowed. So because we didn't see anything happen in the networking tab here, that means that this is a client-side control. So they advise that we should turn off JavaScript to get around this. So turn off JavaScript. I think you can do it from the options menu inside of your browser. So it was like, let me just do a quick look back here. So turn off JavaScript. So open DevTools and then go to the command palette. So it's like here, DevTools. The command palette is, wait, is that the console? No, it's a different thing, right? So command palette, Control-Shift-P. So which one is the command palette in the tabs over here? Is it this one? Control-Shift-P. No, that's the private tab. It's in the developer console. It's none of these. Okay, so type disable JavaScript and hit enter. So I mean, it looks like it's just being done from down here. Here. Oh, that one's Chrome. Okay. let's do a quick search. Firefox disable JavaScript. It's somewhere. To disable JavaScript in Firefox, about config, click accept risk and continue, and then search for JavaScript enabled. I mean, I've done it before like this. So where is JavaScript enabled? There it is. Okay, so JavaScript enabled, true. We're just going to set this to false. We set it to false. We're going to have to turn this back on immediately after we do this. Otherwise, you know, all of our websites will break. That's browser-wide. We only want for that single page. Can we? I didn't know that you could do it that granularly. Okay, now it's true. So we want the single page in the command palette. Firefox, we're looking at DevTools, disable JavaScript. Okay, to disable JavaScript in the Firefox DevTools for the current session and tab, use the settings panel within the DevTools interface. Okay, so open setting, go to the three dots menu, and then in the top corner of the DevTools panel, select settings. Okay, so we go here, we go to the three dots, we go to settings, and is there disable JavaScript? Okay, I found it. Click on disable JavaScript, and then we got an error message here. Show split console. Okay, file not found, great. We click on upload. Okay, success. Okay, so after we do that, we can unclick disable JavaScript. Uploads webshell.php. So, I mean, this is one of the most important parts of doing file upload attacks. You need to know where the file was uploaded to, because if you didn't, I mean, because if you don't, then you can't use your file to do malicious things. So for example, we click here, 0 equals who am I, and we got www data. MXTR Freedom just tipped $3. Thank you. Thank you very much for the Streamlabs tip. Thank you very much. Love your content. Hey, I appreciate that a lot. MXT Freedom, let's give you a special video redeem. How about some Devil's Bedroom? It's a classic show that we're referencing here.
Not every geek with a Commodore 64 can hack into NASA. I mean, these servers have more firewalls than the Devil's Bedroom. Not every geek with a Commodore 64 can hack into NASA. I mean, these servers have more firewalls than the Devil's Bedroom.
Sometimes, I'm sure this guy has probably hacked 1,000 planets by now. Thank you very much, Guybrush Threepwood. That's oh gosh, what was the name? What's the name of that? Monkey Island. Monkey Island is the name of the game. One of these days, I'll play some classic games on stream. That would be pretty fun. Okay, so we can do LSLA. We could. I mean, I guess there's no real flag associated with this with these labs. But okay, I can say that I successfully got our RCE. Submit. Okay, and then complete and continue. Play some OG Doom, because then it runs Doom. We should install Doom on whatever servers that we compromise is what we should do. Bypassing MIME checks. So when developers realize that their client-side controls are easily bypassed, the next logical step is to enforce validation on the server, checking the file as it arrives. A very common yet fundamentally flawed method for doing this is relying on MIME-type multi-purpose internet mail extensions. Okay, the mechanics of MIME validation. When a user selects a file to upload, the browser examines the file's extension, for example PNG or PDF or PHP, mapped by the user's operating system. calculating the appropriate MIME type, and attaches it to the HTTP post request using the content type header. For example, uploading a PNG returns content type image PNG, uploading a PDF sends content type application PDF. And TransUSDT says, name your keyboard and mouse. Name your keyboard and mouse. Keyboard and mouse? I mean, I use like a really cheap keyboard and mouse. I just wanted a corded keyboard and mouse, and I bought basically the cheapest thing I could find on Amazon. SysOS says, relying on user-supplied MIME types, not just using MIME types. So server-side code often attempts to secure the upload by checking the header value. In PHP, this header is automatically parsed and placed into the file's superglobal array. Okay. So the flawed server-side logic looks like this. The server checks the type value provided by the request. If files uploaded file type equals or does not equal image PNG, die. Error, only PNG images are allowed. But if true, save the file. Move uploaded files, uploaded file, temp name, uploads. Okay. They're named Kermit and Froggo. That makes a lot of sense. So the vulnerability, trust in the HTTP header. The critical flaw in this logic is that the server is blindly trusting the HTTP header generated by the client. Just like HTML elements and JavaScript in the browser, HTTP headers are entirely under the user's control before they reach the server. The PHP files uploaded file type variable does not mean that PHP analyzed the file. It simply means PHP read the string of the text the browser sent in the header. To understand the bypass, you have to look at the raw HTTP request that the browser sends when uploading a file known as the multi-part form data. Note the content type header. So content disposition, form data, name, uploaded file, file shell.php, content type, application xphp. So I mean, the thing is that we can manipulate this data to spoof it as something else. How to execute the bypass. Because the validation relies purely on a text string inside the request, bypassing it is trivial. You just need to change the text. Intercept. Turn on your proxy's intercept feature and upload your PHP shell.php file through the web browser. Catch and modify. The proxy pauses the request before it leaves your machine. Locate the line that says content type application xphp just below the file name. Okay, so let's go ahead and demonstrate this. So for this, we need to use a proxy. I'll use Burp Suite because it's the most popular one. And then we'll try uploading this to the target server. So I guess the other thing we need to do is we need to turn on the other lab over here. Just a second, everybody. So we'll just go back to the landing page, and we'll do level 2. So level 2, we've already completed level 1. We'll do level 2, which is the content type check. Click on that. And the MIME police. We check the content type header on the server now. Good. Are you using a virtual machine? Yeah, we're using a Kali Linux virtual machine for everything we're doing on this on the live stream. Okay, so we're just gonna... Oh, we've run out of time already. We can spend a little bit more time doing this topic, because the last topic is kind of open-ended. So what we're going to do is we're going to give ourselves an extra 20 minutes on this topic, and we'll see if we can get everything done in the next 20 minutes or so. Okay, so we're just going to copy this, then we're going to go over to Burp Suite. In Burp Suite, in the proxy tab here, we can open up the Burp Suite browser, which is a web browser that's connected directly to Burp Suite. That means all the traffic that goes between that browser and the and the web server is going to be recorded by Burp Suite. Okay, MOY Nazakat, hello, nice to see you here. Out of bound question, but what should I do to be a network pen tester? I have a background in electrical engineering. So we've got a website that we direct people to, Get Into Cyber. Take a look at the website here from the link, and it'll give you a plan for what kind of research you need to do to get into pen testing. You can also take a look at the education resources over here. And so after you go to the page, go to the link that says Network Pen Testing, and you should be able to see some good resources there. Okay, so we're going to try to upload our malicious, what is it called? Malicious PHP file. So it's going to be in temp HF. Oh, didn't I make a directory? Hold on. Where's my directory? Oh, HacksMarter upload. Here it is. Okay. So web shell PHP. Okay, select this. Upload it. It says security blocked, retrieves MIME type application XPHP. Only image JPEG or image JPEG allowed. Okay, so we're just gonna copy that because this is what they want. Then we're gonna go back to Burp Suite. So Burp Suite would have recorded all of this. So if we go to the proxy HTTP history, we see the post request that we sent when we tried to upload the file. So here is all of the request and response from the browser when we sent that request. We can put this in our repeater tab. So right click on the request, send to repeater. Then in the repeater tab, we can modify the information before we send it off to the server. So down here, we're just going to modify the content type. So content type is going to keep track of what type of file we're sending over. So it currently says application XPHP. We're going to get rid of that, and we're going to replace it with image/JPEG. So this will get around the filter, and it should allow the file upload. So if we send this request, then we get the message success, file uploaded to uploads webshell.php, and then we can access it from we can access it from over here. So it's like uploads/webshell.php. Okay, and we can execute the command by giving a URL parameter. 0 equals who am I? So we're the www data user, and we can also take a look at what's in the current directory. So I mean, I'm pretty sure this is the same directory from the last exercise, but we've got code execution again. If we want to take a look at this in a prettier format, we could take a look at the source code. Okay, so one last exercise to go. We've got about 15 minutes. Let's do it. Okay, so what does the acronym MIME stand for in the context of file type validation? So MIME is mail extension, I think. What does the MI stand for? We saw it back here. Multi-purpose internet mail extensions. Multi-purpose internet. Well, let's just copy this. Okay. Submit this. And when an application performs a MIME check, which specific HTTP header is it inspecting to determine the file type? So it's like web content something something, content type. Content. Is it like this with the dash? Yeah, okay. Submit this. And I got a shell again. Yes, I'm elite hacker now. Sure. Okay, complete and continue, and then we'll move on to the last exercise. Okay, SysOS Master says multi-purpose internet mail extensions RFC to 2045, 2046, and 2047. Thank you for that. And last one is let's do a magic trick. When developers realize that both client-side controls and HTTP headers are entirely controlled by the user, they usually implement the most robust defense available, server-side deep inspection. Instead of asking the file what the file is via HTTP headers, the server actually opens the file and inspects the raw data to determine its true identity. However, even this can be bypassed if the server's logic relies solely on identifying the file format without securing how it is subsequently stored and executed. So we talked about this, not yesterday, in the previous stream, we talked about magic bytes. So magic bytes are how systems identify what kind of file they're looking at, and it's basically looking at the first few bytes of a file for something called the file signature. So magic bytes or file signatures are a sequence of hexadecimal numbers located at the absolute beginning of a file. The operating system and applications use these bytes to instantly identify the file format, completely ignoring the file extension. Okay? So PNG files always start with these bytes. JPEG files always start with these bytes. And GIF files always start with these bytes. When a PHP application uses a secure function, like finfo_file, the server reads these first few bytes. If the bytes match a PNG, the server flags it as a valid image and allows the upload. Okay, is it possible to discuss about my future prospects on any platform? Your future prospects at any platform? I mean, it's kind of like outside of what we're teaching right now. But you know what? You can try giving me a message on Reddit or on Discord. Okay. So, vulnerabilities. How interpreters think. So to defeat deep inspection, an attacker must use a polyglot file, sometimes called a chameleon file. A polyglot is a file that is perfectly valid across multiple different formats simultaneously. This works because of a fundamental quirk in how the PHP interpreter functions. When a web server executes a PHP file, the PHP engine scans the document, looking for the opening PHP tag. It completely ignores everything before that tag and everything after the closing tag, treating it as plain text or binary garbage. Conversely, an image validation script only cares about the magic bytes, that the magic bytes exist at the top of the file. It ignores the random text strings or your payload appended to the end. Creating a polyglot payload. If a server verifies the magic bytes but still saves the file with a PHP extension, either because the user provided it or the user failed to sanitize the file name, an attacker can use this method to embed their payload. So select a valid image, find a small, legitimate PNG or JPEG file on your computer, upload and intercept. Attempt to upload the valid image through the web application, but intercept the request using Burp Suite or Kaido. Locate the file data. In the raw HTTP post request, scroll down to the multi-part form data. Okay, so I'll demonstrate what happens, how to do this right now, okay? So over here, we're going to locate a legitimate PNG file. Playload, I'm doing Freudian slips again, of course. And hi, Prob. Hello, nice to see ya. Okay, so we're going to get an example. So locate 1 by 1, and then we're going to grep by PHP files. No, locate 1 by 1. And we're going to look for the example 1 by 1 PNG file. So we're just going to copy this to our current directory. Okay, and we're going to try uploading this file. And actually, no, but before we do this, yeah, okay, we'll just upload this file directly. So inside of the application here, we're going to turn on the level 3 server, or the level 3 file upload function, the magic byte check. Okay, so we're just going to put this in the Burp Suite browser. Your strong desire to play Doom or Factorio. I've never played Factorio before, but people say that it is very programmatic. So the example image, we're just going to select that and upload it. So success file uploaded to here. We're also going to go back into Burp Suite, and we'll take a look at the post request to level3.php, and we'll put this in the Burp Suite repeater. So in the Burp Suite repeater, we're going to look for the file name, and we're going to change the file name first of all. We're going to change it from... Ooh, what's this up here? We're going to change this to... I don't know. magic.php. Okay, and the content type is going to be image PNG because that's what it is here already. The other thing we're going to do is we're going to show the non-printable characters just so we can see the file header. So the file header is hex89 and then the words PNG, and then right after the carriage return we're going to delete everything in the file. Everything up until the WebKit form boundary. Okay, and then right here we're going to insert our malicious PHP code. And the malicious PHP code is the same code we've been using all this time. Copy that. And then we're going to paste in the malicious PHP code. This comes after the magic bytes. And because the magic bytes are included, it's the server should let us upload this. What has that got to do with desire? What does that have to do with desire? That's a good question. Find type PHP. Well, I mean, we're not exactly looking just for PHP files. But Cypher, hello, nice to see you here. What is up? Okay, so I think this is all we need to do. We changed the file name, and we replaced all of the file content after the magic bytes with our PHP code. We send the request, and success file uploaded to uploads magic.php. So we're just going to copy this, and we're going to access this from the server. So we managed to get one over on the server in 3 ways. Okay, and we're just going to give our payload 0 equals who am I. We are www.data. So the reason why we see this message here first is that this particular script is being interpreted as a PHP file and not a PNG file. But the PNG magic bytes are still here, so that's why we see this. But along with this data, we also see the results of our command. That is in the file, correct? Yes. Okay, so I think we're finished. Let's go ahead and complete the lab, or complete the questions. Okay, what is the common name for the hexadecimal byte sequence located at the very beginning of the file used to identify its format? So these are magic bytes. Submit. Okay. So according to the text, what is the specific 4-byte hexadecimal signature that every PNG file must start with? So it's like 89. What are the other... Let's just go to the text. PNG files here. 8954E47. Beginning or end. Beginning or end? Wait, you can put magic bytes at the end of your file? Okay, so what is the term for a chameleon file that is crafted to be valid in multiple different formats? For example, both a GIF and a PHP script simultaneously. These are polyglot? These are polyglot files. There are magic values at the end of some files. I actually didn't know about that, says OS. I guess I'm learning something new every day. I was able to get a shell again. Yup. Okay, complete and continue. I think we're done. Conclusion. So file upload vulnerability. File upload function represents one of the most critical and complex attack surfaces in modern web applications. Because modern web design necessitates user interaction, whether it's uploading a profile picture, submitting a PDF resume, or attaching a receipt, developers are forced to open a doorway that allows external, untrusted data to be written directly to their server's file system. Okay, let's take a look at the evolution of bypass techniques. So securing file uploads is a perpetual cat and mouse game. As developers implement more complex localized filters, attackers have consistently found creative ways to circumvent them. Relying on a single point of failure is how systems get breached. Okay, Henke says, like PNG, there is an IEND on the last bytes. Oh, awesome. Okay, Fried Popcorn says, how would you know where the file is stored without a page explicitly telling you? So, generally what you would do is you would do some, what is it called? Directory busting. So you can use a directory busting tool, like, let me demonstrate. So over here, we could use something like dirb. Dirb it's not the best example of a directory busting tool, but we can use it. And we would scan the endpoint like this, and it should be able to identify common file upload endpoints, like an uploads directory or other stuff like that. We'll just leave this running for a little bit, and we'll keep on going on with the conclusion. So client-side filters, MIME type validation, blacklisting extensions, deep inspection for magic bytes. These are all methods that might be in place that you could potentially bypass as an attacker. Okay, the golden rule and defense in depth. Never trust the client. Validation must be performed entirely on the server, and it must never rely on a single check. Security requires a multi-layered architectural approach. We should implement strict whitelisting, so never try to guess all the bad file types, which is blacklisting. Only explicitly allow the exact file extensions you need, such as JPEG, PNG, or PDF, and drop absolutely everything else. Rename and randomize. So, I mean, one of the reasons why we were able to access our file is because we knew the name of the file and the server didn't rename the name of the file. So generate a cryptographically secure random string and forcefully append the whitelisted extension. So what you should do when you're storing files on your system is to randomly rename the file to just like a random blob of numbers and letters, so that people wouldn't be able to guess what the uploaded file's name is. Sanitize and re-encode. Pass all uploaded images through an image processing library to redraw the image. Oh, interesting. This permanently destroys any hidden EXIF metadata or appended polyglot payloads. So what you do is you recreate the file and not use the original file contents. That's interesting. Isolate storage. Never store uploaded files on the same directory structure as your application code. Store them in a completely separate domain, for example, in a dedicated file server or a cloud bucket. So I guess if you were to store the files on a completely different system, then your own application would never get compromised. Disable execution. Okay. I have finished the guided lab. Just a second. So Fried Popcorn was asking about how would you be able to tell? I mean, here's the thing. What the directory busting tools are trying to do is they're testing out like as many directory names are in their word list. So if we do like a manual test to the uploads directory here, this gives us a forbidden. So 403 forbidden tells us that this directory exists. It exists on the system, but we don't have access to it, which means that we could potentially identify like an uploads endpoint if we were to fuzz the application and we found this kind of the name of this directory in particular. Okay, Henke says, I always recreate the file like thumb if the file is an image and it showed up on the web app. But yeah, there are a lot of different fuzzing tools we could use. You could use curl, well, not curl. We could use derb, we could use GoBuster, we could use FerrixBuster. There are a bunch of ones that are really popular. We could use FFUF. Okay, so we finished the guided lab. Yes. And then complete. Nikto, yeah, that's another older tool that we like to use sometimes. Oh, I could print out the certificate. Interesting. Okay, so we're done here. So our last activity is going to be about 2 hours long. So let me go ahead and set up the clock for that. Nikto's too slow. Use FerrixBuster. It's much faster. So I mean, I generally tend to use either GoBuster or FerrixBuster as my fuzzing tools. Sometimes I use FFUF as well. Anyways, we're finished with HacKSmarter. Let's close this out. And what we're doing for our last thing today is we're taking a look at CTFLearn. CTFLearn.com. FerrixBuster is too slow. Use a number 12 pipe branch. I mean, depends on what you want the server to do after you're finished. Okay, so I guess for me, I'll hide my solved challenges. Hide solved, unsolved, unsolved. Okay, so what category of CTF challenge do we want to do today? So the last topic we're doing is we're going to be doing some free CTF challenges, any category we like. We could do reverse engineering, we could do binary exploitation, we could do forensics. Let's see, can you explain the difference between fuzzing and brute force? So, I mean, brute force, fuzzing is a type of brute force. But generally, when we talk about, or brute force is a type of fuzzing. We're basically sending a bunch of arbitrary data to the server, and we're seeing what gets a different response. When we talk about brute force, we're usually referring to like brute forcing credentials, but a lot of people don't realize that. What is the word? Directory busting is a type of brute force attack. Okay, so let's see. Let's use some forensics. I've been kind of on a forensics kick in the last little bit. So let's take a look at some forensics challenges. Unless somebody else has a different suggestion. Bonus points for the exact XKCD. Oh, number 12 pipe wrench. Okay, okay. I don't think I've read that one. Okay, so we got, the only challenges we have, oh, we've got an easy one over here. Let's start with an easy level challenge. Let's do some BinX. We'll do one forensics challenge first, and then we'll try doing a BinX. Okay, so if anybody wants to give us a try, this is the challenge over here. So what I need to pay attention to is I need to pay attention to doing my write-ups. Because if you do a challenge and you don't do a write-up for it, then you didn't really do it. If you didn't do it and you didn't document it, if you did it but you didn't document it, you didn't do it, is what we're trying to say. Let's see, CTFLearn here. What challenge? This one is called Minions, the Minions challenge. Okay, so where are we? We're making our so this is forensics, CTFLearn, and this one's called Minions. So record a few different things, the URL, the concept, and the method of solve. Okay, so let me grab that URL. The concept here is, well, we're doing forensics. I'm not too sure what kind of forensics we're doing yet. We will find out shortly. I have no active memories of that. My sympathy if you know where that comes from. Active memories. I'm not sure. Hey, minions have stolen my flag encoded a few dozen times in one cipher and hidden it somewhere. What? Oh, okay. Can you help me? Tip, decode the flag until you get a sentence. Decode the flag until you get a sentence. Well, I mean, this seems like a... Oh boy, we're going to be doing a lot of cipher encoding and, you know, decoding and stuff like that. Alright, so we've got mega.nz. That's everybody's favorite file hosting platform. Translate it to English. I translated it to English. Oh, what are we talking about? Old New Zealand. Okay, so this is the PNG file. So I mean, I guess we need to copy the PNG file, copy the link, and then download it. Can we directly download it from here? Copy image link, okay, and then we'll make this directory minions. Save image as. Oh, let's just try. No, that's not going to work. That's not going to work. Okay, we'll save image as. Okay, so where do we put it? Temp HF minions. Save it. There's a circle with an arrow down, top right of the image. Oh, this one here, yeah. I mean, I think we downloaded it properly anyways. Untitled.png. Let's just open it, just to make sure it's the same thing. Okay, this should be the same file. And, so it's a PNG file. There's EXIF data in all of these media files, so we'll try taking a look. Trailer data after PNG IND chunk. Okay, so this is usually indicative of like an embedded file. So if there's an embedded file in here, we could probably get it out with binwalk or foremost. Foremost on untitled. We got an output directory, and we got a PNG file, audit.txt. Let's see if there's something different in here. we'll exif tool this as well. Okay, so this file that we extracted, it doesn't give us the message, whatever ind chunk after whatever. So let's take a look. Looks like the same image. I guess another thing that we can do is we can run strings on this. So here's our strings. What keyboard do you have? It's a Magic Eagle keyboard. I'm sure if you look up Magic Eagle keyboard on Google, you'll probably be able to find it. It sounds like it wants to be clicky, but it isn't. It's a pretty cheap keyboard, is what it is. Dsteg, just check the data on the image. Yeah, Henke, you got it right. So steganography tools for PNG files are different from the ones on JPEG tools. So zsteg, I think, is the name of the command. Nothing. These. Do I have TLDR in here? TLDR. Yeah. So we'll TLDR zsteg. Steganography detection tool for PNG and bitmap file formats. Detect embedded data in the PNG. Detect embedded data in the PNG. So I wasn't able to find anything here. Extracting only prime pixels and inverting bits. I mean, we could give this a try. Try it on the original file, not the output. Okay, we'll give it a try. So the original file was untitled.png. So zsteg untitled. Huh. Interesting. Oh. You still not here? Nothing here. Text. HTTP. Mega. Okay. You still here? Nothing here. Okay. I think what we need to do is we need to go to this new. It's a RAR file. No, I think this is pointing to another. It's pointing to another file download. So I think I'm gonna try looking at this. Okay, and just so nobody is feeling left out, I'll share this with chat if they want to try. Dino Love? Is it a dinosaur? Okay, let's... Wait, is this the same thing? Only a few... Oh, okay. It's another image. Okay, we'll download it. Only a few steps.jpg. Sure. And we'll move it. New minion, yep. New minion, who this? Alright, so we'll exif tool it. Nothing interesting in the exif data? Or at least I don't think so. Banana? Rar means you look tasty in dinosaur or something. I'm sure it does. So I'm looking out for any suspicious looking information. Okay. Still can't see anything super. That thing is all over the place. It said something about binary data. Binary data? I mean, we could also do some steganography with this. So we would do like stegseek. Stegseek on only a few steps.jpg. And couldn't find a valid passphrase, so it's probably not embedded with steg height information. The other thing we could do is we could take a look at the strings. What? U1 almost.jpg. Where is this located? I would suggest stegseek. Yeah, we just tried stegseek. U1 almost.jpg. I think we can also strings with minimum string value. Some like 8 maybe? Yeah. U1 almost.jpg. So we should probably locate that. U1 almost.jpg. We could probably locate this using something like grep. Is that a password? I don't know what it is really. But what we can, okay, we'll grep it. Grep for the pattern this. Maybe we need to make it like this. For in this. Binary file matches. Binary file matches. It's not going to show me. I guess we could XXD this as well, right? XXD. And we look for. Okay, so you want almost.jpg. You can try grepping it out. So there's 2 mentions of this. There's 2 mentions of this. We can also get the lines around them. So there's reference to some sort of RAR file here. So there might be something embedded in here, right? Could we use like foremost to try to so this is JPEG image data, okay. I mean, the other thing we could do is we could try inspecting this to see if there's any text or something hiding in here. I don't think there is. Yeah, I don't think so. That's a JPEG. You can use steg hide to extract, maybe use RawQ to brute force the password. Yeah, I mean, we've tried stegseek already. Stegseek wasn't able to find anything. But I mean, we could try using another mode of stegseek. So let's see. We can supply our own word list. We could do crack a stego file using a word list. Seed, crack a stego file by attempting all embedding patterns. This mode can be used to detect a file embedded by steghide. In the case the file was encoded without encryption, this mode will recover the embedded file. Well, we'll give it a try. Probably covered this, what challenges is from. So this is from CTFLearn. And you can find it over here. And this is going to take a while. I guess we can do something else in the meantime. No worries, Jordan. Okay, so only is 2steps.jpg. Can we foremost? Actually, let's get rid of the previous output directory here. And we'll try foremost on this. Let's see if anything came out. So we got another JPEG, it looks like. Probably a thumbnail, but maybe not. Yeah, probably the same thumbnail. Might use crack file.jpg wordlist.rockU.txt. Hey, what is up? C. Calandro? Hello, nice to see you here. So why not use crack? I mean, we've already done crack with stegseek. Crack with stegseek is the default, and it uses RockU as the default list. I mean, we can make it explicit, sure. Hold on. Do you have a Discord channel? Yeah, we do. Discord is over here. Reddit is over here if you want Reddit as well. Okay, I think we finished. We finished doing the seed cracking with the stegseek. Yeah, wasn't able to find the valid phrase, but let's take a look over here. Minions have stolen my flag, encoded it a few times in one cipher, and hidden it somewhere here. So we're looking for an encoded cipher. Maybe we're looking for the encoded cipher in this image. Can you open the file with RAR? So string, if we run strings on this, and then we grep out for RAR, or RAR, yeah. Okay, RAR u1 almost.jpg. u1 almost.jpg. These are the strings. So this is an RAR, unrar, unrar. Okay, so how do you run unrar on here? unrar command, switch 1, switch 2. Unrar extract, unrar E. Okay. Extracting U1 almost.jpg, all okay. Wait, so did we... It did work. Wow. SysOS, that was a great suggestion, thank you. So U1 almost.jpg. We've got it here. I mean, what kind of file is this? This is another JPEG file. Creator GDJPEG, great. Let's just try some stegseek on this. Okay, wasn't able to find valid password. Passphrase. I guess we could also take a look at the strings for this thing. And get just stuff that's over 8 characters long. Ah, okay. We found what looks like a flag. So CTF something something something. All right. Let's locate this with grep. Just to see what the stuff looks like, the data. No, we're looking for the pattern CTF in U1 almost.jpg. Oh, this doesn't work for grep. Grep doesn't work on binary files. I think what we need to do is we need to do XXD. Okay. Base64 encoded? Maybe. That's corrupt. Maybe fix some magic bytes. Is it corrupt? Really? Does it have RAR again? That's a good question. Okay, Yazanji says, I have a question. I'm learning Python and want to know if is it bad to do things with Python like make video games? With Pygame, to understand the language, more to have fun outside of hacking. I mean, if you want to build games using Pygame, and that's the fun thing you want to do, why not? Nobody's going to arrest you. Okay, what command were we doing again? It's XXD on this, and then grep out CTF. Okay, so this is how we're going to determine if we're looking at the exact thing. So it's after, right? So after 6 lines, maybe? So this is the end of... Yeah, this looks like base64 information. So we could probably plug this into... We could probably plug this into CyberChef. This is probably the end of the base64 information. So echo it out, echo n, this stuff, base64 decode. And it's even more base64. Except the fun police, they just don't want to see anybody having fun. Okay, so it looks like it's double base64 encoded, so we have to double base64 decode it. And then this looks like even more base64 encoding. So we triple base64 decode. And it looks like it's even further decoded. Minions are cool. Okay, that's great. So with the flag wrapper, then the flag is CTF minions are cool, like this. Let's try to give this a try. Let's give this a try and see if this is the correct flag. I'm going to shut down Burp Suite because I'm not using it right now. JC on a motorbike, yeah. Okay, so boom, CTF minions are cool. Solved. Okay, that was it. That was it. Why was that fun? Why? That was fun? Is JC? JC is the unfun police. Maybe. Okay, well, let's talk about what we, well, how we solved the challenge. So, back over here. And, says OS Master, that was great of you to suggest using the unrar program to get the original file. Well, to get one of the files out. That was very handy. Okay, concept. What are we talking about here? We're talking about embedded files. We're also talking about. Did we do any steganography there? I kind of forget. Nice CTF. Thanks. Well, I shouldn't say thanks. It's not my CTF. So we're talking about embedded files, and we're also talking about base64 encoded strings. So method to solve. So the first thing we do is download the image from the link, and use, what did we use? We used like foremost on the first one. Use the, oh, no, we didn't use foremost. What did we use? What did we use to extract that first one? I do not think we ended up using any stego. Thank you very much for the follow, Kukan Nasa. Thank you. We'd used zsteg on the original file. Right. Did we use zsteg on the original file? Hold on. RM. Let's get rid of output. And then we'll get rid of this file. So the original PNG file is this. Let's also get rid of this. We're trying to reverse engineering how we solve this thing again. So we did we do zsteg? Yeah, we did zsteg. So zsteg is some steganography stuff. I mean, the other thing is, it says rar. So if it says rar, should we have tried to unrar this file then? Unrar for untitled. So that extracted .txt. Oh, let's make sure we're... okay. So we didn't need to use zsteg. We just need to use unrar. Save that as a file. Yeah. So if we take... I mean, I'm pretty sure that we could have picked this up by looking at the strings. So looking at strings for untitled.png and piping into less. Because where was the message for rar? was this one, right? RAR. Okay, let's see the stuff around that. You still here, nothing here, 16. Okay. I think zsteg was meant to lead you into unrar. So why it worked? Because it was an uncompressed rar. Okay, so let's put that in the write-up. Use the zsteg program to inspect the file. Okay, we'll include our command. That's in bytes format, not ASCII, so it's not showed using strings. Oh, does it not appear in strings? I mean, we were able to find this stuff. Oh, this stuff doesn't appear in strings. Okay, so if we run strings by itself, we can't grep this out. No, we can. Hold on. So if we just run strings on untitled, it's got all this stuff. Ah, okay. So this is just at the end. This is the IEND, so the end of the PNG file, and then it's got the RAR file tacked onto the end. So I guess we don't really need to use the zsteg. We just need to use strings. We just need to use strings. So we just use strings to inspect the file. So strings. Ooh, what was the file originally called? heyu.png. Okay, we see another link near the end of the file, or near the end of the strings output. Okay, and then we'll include it. It's just appended to the images, yeah. So this over here, copy that. So after downloading this file, we can... So after we download this file, so it's this one, only a few steps.jpg. So we'll copy that again. And then... what did we do after this? We ran strings again, I'm pretty sure, right? u1 almost.jpg. So u1 almost.jpg, we grepped it out. No, we run xxd. We run xxd and we grepped for u1. And then we saw that there was a reference to a RAR file in here. Okay, let's record that. So after downloading the file, we look at strings again. And we see reference to a JPEG file. Okay, so the command was just like strings. What was it called? Only a few steps. So if we use XXD, we can identify where this file is referenced. Referenced in the what would we call it again? Where this file is referenced in the bytes of the file. So what we do is we do our XXD command, looking for u1almost.jpg, and this points us at the RAR. So this lets us know that the file could be a RAR file. And then from there, we run unrar. Unrar on, what was it called? Only this one. And that extracts ualmost1.jpg. Let me copy the unrar command. And then we look at the strings of the file again. We sure do use a lot of strings. Not that it's a bad thing. So strings. So this is where we found that there was like this CTF string over here. So I guess in this case we would do strings with the filter. This is a lot less. Yeah. Okay, so we run strings with the filter, and this leads us to the base64 encoded string. Copy that for the write-up. This points us to a base64 encoded string. We can we have to decode it about 5 or 6 times before we get the flag. Okay, and we'll just use grab this. So it's echo n, this thing, and yeah. So base64 decode once, twice, 3, 4 times. I guess it was only 4 times. 1, 2, 3, 4. Okay, so we'll just copy this command and then we're finished with our write-up. Done. Okay, everybody, let's move on to another challenge. So this is done. Don't need any of this. Okay, so I think somebody requested a binary, like a binary challenge. So let's go ahead and find one of those. So let's see, we'll do binary, and we'll try an easy binary one. With time to spare. Time to spare, yeah. How much time did we spend on that? An hour and 16 minutes. Yeah, we didn't actually spend all that much time on this. So I think we spent something in the neighborhood of like 15 or 20 minutes working on this. Leak me, positive challenge, domain name resolver, glob, readme. School, secret, runner, random malloc, cookies, 2 times 16. Well, I mean, this is a nice, easy one. It's only worth 10 points. Well, let's give it a shot. Okay, so this is a... I secured my app with a random password. Try to crack it. Random password, you say? Alright, everybody wants to give this a try? Here you go. And there's also a netcat command. I'll give you this as well. And there's a task gz tar file. Okay, well... So this challenge is called Secret. We'll make another directory for this. And we'll copy over the file that we just downloaded. Move. What was the file called? Task. So this is a gzip file. We need to gunzip it. And now there's a tar file, tar xvg task, task and task.c. Okay, expose that secret. Well, we're trying to. Task.c and task.tar. I mean, we don't need this one anymore. Task.c. So if we're given the C source code, we should be able to figure out where the vulnerability is, right? So cat task.c. And you know what? What I'm going to do is I'm going to paste this into pastebin so everybody can take a look at it. Okay? Pastebin. Create new paste. Okay, so if everybody wants to take a look at this code, here you go. So before we start, what I'm going to do is I'm going to start my my write-up for this. Okay, so we're going to start it over here. You should get one of those clipboard to pastebin tools. I mean, I don't think I used pastebin as much as I think I do, but maybe yeah. Okay, so binary hacking, simple BOF. We made one for this. This one's called Secret. Nope. Just a second. Secret.md. Okay, we need the URL, we need the concept, the source code, and then the method of solving it. Could also be a gist, maybe. Okay, so I think I just grabbed the source code, so I'm going to just paste it in here. And I think I'll also grab the URL, the challenge URL concept. It's going to be some sort of buffer. It's going to be some sort of buffer overflow, I think. But let's take a closer look. Nano task.c. Okay, so print flag, flag.txt, missing flag file. fgets flag fgets, fgets is secure. This is not the vulnerable version of the function. Here's your prize. Void guess me. Guess me. So this is another function. Secret password is 33 bytes large. So we got memset. Okay, so memset user input dash memset secret password random function. So I guess we're taking a look at like 32 character passwords. So secret password is random modulo 6 plus 97. Oh, okay. So each character in the password is being modified. Okay, let's see. Put no flag for you, else print flag. So where do they put in, where do they take in our user input? String length of user input. Secret password. Password is too short. Okay, so you need to put in exactly 32 characters. Otherwise it'll tell you that your password is too short. So this is, I mean, there's a couple of different things that this could be. I'm guessing that this is going to be some sort of, what is it called? String formatting? Like a string formatting vulnerability? What are those called? So task.c. Let's try running the thing. So task. Oh, okay. Another thing we need to do is we need to include the flag file in here. So echo HackerFrogs, like and subscribe to flag.txt. Okay. So we'll run task. And I wonder why task is taking so long to come back to us. You know what? I think I'm a little paranoid about this. So I'm just going to try doing this command instead. Okay, due to rising costs and maintenance efforts, this challenge has been open sourced here. GitHub.com, Rivet, CTF challenges, master community. Okay, so let's copy this and go over to wherever it is and see what's actually going on. We're looking for secret. Is this the only one? Yeah, this is the only one. Okay, I secured my app with a random password. Try to crack it. Wait, is this? Yeah, this is the same netcat command. So this is not... Due to rising costs and maintenance efforts, this challenge has been open sourced here. So I guess we don't get a flag? We don't get a flag because we can't actually access the official thing. Okay, private, public. What's going on here? So this is the public file. We got this already. Okay, task C, flag CTFLearn.txt. You know what? Let me download the precompiled binary over here. Okay, and then we'll view raw. Well, I mean, we can copy the raw file as well. Copy raw file. We want to download this thing. Download raw file. Okay, task. Let's just get rid of the task file that we've gotten here already. And then copy over. Okay, and then make it executable. Yeah, it's funny that this doesn't really do anything when we run it. Is it because of some sort of misconfiguration on my end? So int main, so it runs guess me. So it does the settings over here, and then it runs guess me, and then it exits. So guess me is this whole thing where is anybody else trying this challenge? If anybody else is attempting this challenge, let us know if you're able to get the binary to run. Otherwise, we're gonna have to move on to another challenge. I mean, if we're not actually getting a flag out of this challenge, although I guess we could just look at the flag for CTFLearn. What's the name of the challenge? The name of the challenge is secret. This one over here. So discussion, sort of brute forced it. So you say it's math related. I guess in order for the guesswork to be more accurate. Never mind, it's totally unrelated. I mean, in order to do the challenge, we need to be able to run the binary, which I'm not able to do. So maybe we'll move on to another challenge. We got slope, we got 2 times 16. These are all done by the same author. Can you post here the GitHub linked secret to review the code? Yeah, I can do that. Anyways, let's commit this. You probably want to take the stuff, look at the stuff here, like the task.c file. Okay. Yeah, because I mean the thing is that every one of these challenges is made by the same author, and the author has taken all of this stuff offline. So let's try a reverse engineering challenge instead. So we'll do reversing. Difficulty easy. And let's try one of these reversing challenges. How about this one over here? Riyadh. Okay, so if you want to try this out yourself, here you go. So we haven't done one for reversing it here. Okay, let's make a new file. Thank you very much. Anime T has resubscribed with Prime for 2 months in a row. Thank you very much, Anime T. Let's give you some fun video redeems. How about some Hack the Planet? We haven't done this in a while.
Hack the planet! Hack the planet! Shut up and get it.
Okay, so one more time, we'll record the URL, the concept, and the method of solve. Okay, so where's that URL here? Let's take a look at the challenge description. So another entry-level reversing challenge. If you're new to reversing, you probably want to try my Reykjavik challenge before attempting this challenge. Good luck. The flag is hidden inside the Riyadh program. Solve the challenge, get the flag, and I've included the encrypted sources used to create the challenge in the riyadh.zip file. If you do the work of solving the challenge, I'm providing the challenge source code, C++ and Python, if you're interested in studying the sources after solving the challenge. I think this is a great way to improve your reversing skills while learning. Please don't share the sources or flag after you solve the challenge. Okay, and we got riyadh.zip, and let's go ahead and do that. Done. Okay. Directory is called Riyadh. Move from the downloads file here, unzip it. Oh, why didn't I move into the directory? I should have done that. Silly me. Okay, let's do that again. Okay, so what do we got? Sources.zip.enc. I guess we can unzip this with the password or something. And we got the readme here as well. Cat readme. Okay, so thanks for help working on the Riyadh reversing challenge. I hope you enjoy it. If you're new to reversing, you may want to solve my Reykjavik challenge. Solve the challenge, get the flag, and decrypt the sources. Decrypt with OpenSSL. Oh, we need to use the flag to decrypt the sources file. Okay. I think... Well, we'll, So the Riyadh file probably is asking for like a password or something. Welcome to CTFLearn Riyadh Reversing Challenge. Compile options. Compile options. Usage Riyadh flag. I guess what we should be doing is we should be usage Riyadh flag. Riyadh flag. I mean, okay. // You entered the wrong flag. Okay, so what they want us to do is they want us to get the flag and to check against the flag by running the binary, right? So let's take a look at the binary with our favorite reverse engineering tool, Radare 2. Well, Radare 3 is probably not the best one, but I used to love watching hackers when I was a teen. Hey, Anime T, what is up? Okay, so we'll analyze the binary, and then let's take a look at what's going on for the functions. Functions. We've got the entry point. We've got main. CTFLearn hidden flag? Why is there a function called CTFLearn hidden flag? Alright, well, maybe we need to take a look in there. Maybe we need to take a look at the main function. Let's look at the main function first. So, I mean, I'm not really great at taking a look at raw assembly instructions, but I'll give it a shot. This seems like a kind of long program, huh? Well, for a CTF challenge anyways. Okay, so I think secret section size named text. Okay, XOR. Yeah, that function is like, don't be suspicious, don't be suspicious. Project Omega, hey, what is up? So, I mean, I'm going to see if there's any reference. I mean, the other thing that we could do, call sim CTFLearn hidden flag. Sim CTFLearn hidden flag. Okay. So compare. So they do the comparison. They get the user input over here. No. This is a print function. That's the print function. Just a second. Let's. Maybe it's too obvious. I mean, it's probably the obvious options in these easy challenges are usually the right thing to look at. Okay, so welcome to, so that you're looking for a usage. Ah, okay. So they're actually looking for, they're testing the argument. They're testing the binary argument. So we need to figure out where the binary argument is stored. So they get the compile options over here, sure, it prints out all that stuff. And then they compare 1 with our 12D. So this, what are they called again? They're called, oh gosh. They're called registers. Yeah, the registers, the memory register. Okay. So call sim CTFLearn hidden flag. And call sim operator delete. Maybe the number 1. Maybe 1 is for the number of arguments. Oh, 1 is like the first argument? I mean, that could be it. Okay, I think it's time to take a look at this weird function over here. So sim CTFLearn hidden flag. We'll take a look. So what is this? This is very short. So there's nothing here. CTFLearn hidden flag. There's just a ret, like a ret command. There's a ret command, and then there's like a. This is just like a function epilogue, right? So wait, didn't? I mean, it couldn't actually be this, could it? That'd be too obvious. Nope. You entered the wrong flag, so that this is not the flag we're looking for. And the other thing we could do is we could take a look at this inside of Ghidra, which is another program that we like to use for reverse engineering. Jackson, America, hello, nice to see you here. What is up? So let's run Ghidra from over here. What are you doing right now? So we're just doing some reverse engineering stuff. We've got a challenge over here. Run strings on it. Oh, that's true. We could run strings on it. Hold on. So run strings. It's actually not very much. All done. All done. We don't even see the "that's not the correct flag" message in here. We'd usually be up near the top. The other thing we could do is we could just we could take a look at the strings. What was the command to look at strings again? I think it was like dare list strings. Look for it all done in the disassembly, maybe. So it would probably be the all done message would probably be in the would probably be in the main function. Please teach me everything? Well, I mean, just keep watching, I suppose. Okay, so we've got Ghidra here. Rev has not been analyzed. Would you like to analyze it now? Nope. We want to open up a new project. Where do we access new project? We can close this. Close tool. New project. And we'll call this, what is this called? Riyadh? Okay, we can import the binary. Okay, and then we'll open it up and inspect it. Riyadh has not been analyzed. Would you analyze it now? Would you like to analyze it now? Yes. Analyze. Okay. All right, so let's see. We got our functions. So CTF hidden flag is here, but there's nothing here. All it does is return. So CTF learn hidden flag is a function that just returns. If we take a look at the main function, so I mean the other thing we could do is we could take a look at the strings. Right, so data types, built-in types, probably want to look at here. Strings UTF-8. Nothing here. There's all done in main. Is it down here? All done. Else puts all done. Yeah, I see it. If ivar equals 0, cvar3 equals oh, okay. So I think we're doing a check character by character in here. So it's checking for \0. That's a weird thing to check for. So how many of these are there? So it's from 0 to FF. FF is no. 7. Hexadecimal 7, hexadecimal 8, 9, 10, 9, A, B, C, D, E, F, F. Hexadecimal F is 15, so it's like 15 characters. So 15 characters each time it's checking for \0. 16 characters, yeah. So FF is, because we start counting from 0, it's 16 characters. So, I mean, I see 16 characters. It's looking for \0 over and over again. But, I mean, it can't be literally \0. That doesn't make any sense. Okay. Let's put on some new music. Got about 45 minutes left for the stream. Dungeon of the Endless, anyone? No such file or directory. Oh. Okay, yeah, this is not the flag it's looking for. He uses backslashes anyways. Don't talk to any Windows people. Windows people love using the backslash. It's initialized with \0, not the flag. So the first comparison, the first comp is a false flag, then there's an XOR with loop to just do a breakpoint at the file comparison at base plus 168, and then view the contents of the base pointer. So usually in these easy reverse engineering challenges, I tend to look at the comparison. Yeah, so this is the all done message over here. I tend to pay more attention to the comparison that is done at the end of the program. But it's a pretty... There's a lot of like jumbly mess in here. Okay, Amit says, so what jobs can I get after learning CTF, Hack the Box and Pico CTF? Amit, what is your goal? I mean, depending on what your goal is, you might not want to be using Hack the Box or Pico CTF. You need to run it with Docker? You need to run it with Docker. That... But why? Why would they set it up like that? It doesn't make me... Oh, I don't know. It'd be good if they could like explain what's going on. Okay, so let's see. Omar says, I like GNU Debugger. It's clean with small binaries. Because the original setup was like that probably, and they're not hosting it anymore. Oh, wow. So I guess it's not super practical to look at. The guy likes containers, I guess. The goal is earning a lot of money. Oh, the goal is earning a lot of money. Don't get into cybersecurity. If your goal of getting into cybersecurity is earning a lot of money, don't get into cybersecurity. I'm not saying that people in cybersecurity don't earn a lot of money. It's just that that shouldn't be your primary motivation for getting into cybersecurity. But what if you're really, really good? Really, really good at cybersecurity? What if you're really, really good at cybersecurity, but your primary motivation is can you check for all the strings on Ghidra? Yeah, we can. Okay, so let's see. We're looking for data types. Data types in Riyadh. Yep, this is binary stuff. It's on the menu search. Search for strings. Search for strings, minimum length 5 Pascal strings. Okay. I really need to take a course on how to use Ghidra. Okay, Emmett says, just kidding, still learning Stack and learning and thinking of learning cybersecurity. One more skill added to my resume to get a job. For the amount of money, the OJs. Omar says, goal is earning a lot of money. Future ransomware group affiliate. You should check the all block to search all the strings. Go back in. Search for strings. All blocks. Loaded blocks and all blocks. Okay. So we got our strings over here. Can we make this any bigger? Because it's a bit... So we have the actual strings here in this column. We got some string compare. Compile options all done. I mean, a couple of these stand out, but I don't think they're necessarily flags. CTFLearn hidden flag. I mean, that can't be it, can it? Code unit label location. So can we... Can we copy this? Copy. Just copy. And what is this thing? CTFLearn flag. So what was your goal when you started learning cybersecurity? What was my goal when I started learning cybersecurity? Make a big change in my career. This is not the flag we're looking for. Sorry, what was your original question? Your original question was, should you use Hack the Box or Pico CTF, and what kind of job can you get after learning those platforms? I mean, those platforms usually aim a person at Hack the Box in particular aims people at doing like pen testing stuff. Check out this website here. It'll let you know what kind of options are available in the cybersecurity field. Of course, there's more than what's available there. You need to do your own research. I can point you towards I can point you towards resources and stuff. Did you teach the cloud security that you didn't do last? Yeah, we did the cloud security stuff on Wednesday. Can you share the link for the challenge? Sure. It's over here. Can lead a horse to water, but you can't make it drink. I mean, the thing is that I'm trying to help people learn about cybersecurity, but the reality is that people who get into cybersecurity are usually people who are very self-motivated, and the kind of like paradox of what I'm trying to do is that I'm trying to make it really easy for people to find resources for cybersecurity, but the reality is that people who are best suited to learn cybersecurity are people who are able to find their own resources. So it's kind of a chicken and egg thing. Okay, discussion, very cool. Love these challenges, learned a lot. Catch-22, kind of. So inside of our main function here, there's a lot of... I guess what we need to do is we need to identify... We need to identify where the argument goes. So I mean, I guess what we could do is we could set up a breakpoint. So your argument usually ends up in like a standard location. Okay, I watch for entertainment purposes. I like watching you solve these problems. Oh, thank you very much, Moosey Style. So the absolute end of the program is down here, but what we probably want to do is we want to identify the comparison, where the comparison point is. Can you run it on GDB and disassemble the main? I mean, the main is disassembled. I don't even know GDB commands. So it's like GDB and then the name of the binary, and then what is even the command to disassemble at main? GDB/readd and then disassemble main, just the whole word. C to continue without paging. Ret for more. Oh, that's a lot of... Well, I mean, if you want to, I can copy this all. I can copy this to, like, and copy this to a paste bin so you can look at it. You have to do GEF to set disassembly flavor intel first. Hold on. Here's the output if you want to take a look. Call, load effective address, jump, test, test. And some compies here too. Break on the function CTF labs. So the CTF labs function is down. Here. Call sim. So here's the instruction to call that. Call the function. Okay, so Omar says the flag is being written from the Z4 message, 5PC at plus 146, from F message and Zormas. So you can just pull them from memory and Zor them together, or do a breakpoint at base plus 168. Okay. So if we set it over here, and then... So we do OD with test DC. We hit the breakpoint here. And okay, the flag is being written from, let's see, pull them from memory and XOR them. It's being written on RBP. Main plus 90. Okay, so I mean, we've got... disassembly at main. You're talking about main plus 90? Move RDI into RBP. Then call the string compare. Test EAX. So this is... Okay, break at rbase something. I'll give it a try. Omar. So do the breakpoint at base plus 168. It's better to do a break on compare at main plus 168. Can't do that without a process debug. We don't have it. And of assembler dump. Okay, I have no idea what the instructions are in GNU Debugger. I'm only used to doing the stuff inside of Radara 2. And I think main plus written in RBP. RBP is move RDI RBP into RDI here. I think this is the instruction we're looking for. And then there's like a comparison, right? Where's the comparison? Compare IRAX test. Check message 5 on Radar. You'll find a compare after XOR in main. So this is main, sure. Message 5, message 4, message 6. Message 7. Message 5, okay? Message 5, you'll find a compare after XOR. So this is a separate function, right? Message 5 character will disassemble this. And you said something about a comparison after an XOR. Okay. So I'm looking for the compare after the XOR. XORs happen here. There's a comparison. So there's a comparison right at the end over here. Compare RAX with decimal 31. So add 1 to RAX, and then compare RAX with... Okay, it's at hex C1A8. Hex C1A8. I meant after the call to the M message 5 function. This function is writing the flag from F message and XOR mask. XOR mask, in your case, has the XOR keys, and F message is the XORed flag. Okay, so meant after the call to the message 5 function. Okay, so if we're still looking at main then. We're looking for the message 5 function call. Up. Or down here. Message 3. Message 5. Okay. And then you say that we're supposed to take a look at the XOR function and then the comparison over here, right? So it's hex 5587. 5587. Do a breakpoint here. Okay, we'll set the breakpoint. Base address should not be larger than the breakpoint address. Base address should... why didn't it like that? Okay, reset the thing. The flag should be at RBP, I assume. Try printing its contents. RBP. Staffing failed. OD. Test. Set the breakpoint. Let me try looking for that again. So we're looking for the comparison after message 5. Message 5, XOR, comparison. Why doesn't it want to set the breakpoint here? This is a legitimate address. GDB, I do VM map to get the base address and the offset. That's why I break with rebase in GDB. Okay, that worked. Great. Then we run the program. Then we hit the breakpoint. So this is not the breakpoint of the address we're looking for. So we'll just run it again. You entered the wrong flag. We set the breakpoint here, but it didn't go through. We hit the breakpoint at 149, and I think 9149 is where the call to the flag thing happened. Yeah, this one here. I think, let me unset that breakpoint. String length check before this instruction. Gotta run it with 30 characters. 30 characters, 30 times maybe. 30 characters, huh? Let me get that. So Python command print A times 30. Give this a try. Okay, OOC with this. Run it. 49, okay. Hit the breakpoint here. So we hit another breakpoint, and this is the one we want. So they say that the flag, Omar says that the flag should be at RBP. So if we take a look at the RBP is this address here. We can take a look at the contents. Wow, Omar, geez, you were right. I mean, I would never have figured it out. I don't think I would have figured it out on my own because I saw that code and my mind went blank. That is pretty cool. I mean, the ability... what I usually do is I try to find where the comparison point is and then understand what's going on. Copy that here. I mean, that's the flag. You should do this kind of thing more. I really want to. It's just that my skills are not very good. I would really want to... I really want to do a lot more learning offline before I do learning... Well, before I start solving the stuff on the live stream. Otherwise, I make a fool of myself. So if we go back here and then run the Riyadh program with this, see how it reacts. All done. Okay. Congratulations, you found the flag. It's funny how congratulations, you found the flag isn't in the strings. So they have to generate this message inside the program. Fix is doing it more. Yeah, the fix is doing it more. I mean, the thing is that I don't really want to struggle. I don't want to struggle super hard on the live stream because it's not very fun for people to watch me not getting the job done for hours at a time. But yeah, what I should do is I should take a look at a write-up for this challenge to try to understand what the heck is going on. Make it a struggle stream. I don't know. I'm not too sure if people would really appreciate that. One of the reasons why I like to do like a mixture of demos and challenges is because, well, it lets people, it lets me switch up my content. So I'll go from a demo to like a lesson to a challenge, and then it's not just hours and hours of me struggling. But yeah, I really should try to include more of this. And yeah, okay. So I think I'll submit the flag, although I really didn't earn this. I'll try to disassemble. Well, I'll try to take a look at some write-ups to understand what's going on with that. Okay, so submit. Thank you very much, Omar. There are also a couple of false flags at each comparison instruction, like CTFLearn reversing is easy. It returns, you found the false flag, but it's not that easy, dude. People do go to, oh, that's true. People do go to other streams. Solved. This was, I mean, I won't rate the challenge because I'm not really qualified to rate it. I'll come back to this challenge and I'll take a look at some write-ups, because I really need to refine my workflow when it comes to these reverse engineering challenges. But how much time do we have left? I think we can do like an easy like web challenge or something. It would be nice to be able to end the stream on a dub. But it looks like, hold on. It looks like the CTFLearn website is a bit laggy right now. I mean, the CTFLearn website is a bit laggy at the best of times. Thank you very much for following Energy Star. What did you do in the challenge? I got schooled. I got schooled in this challenge. Okay, so I think you missed the whole thing, Energy Star? Oh, okay, okay. It was just a lot of looking at disassembly code and trying to figure out what the heck was going on. Okay, so it looks like CTFLearn is... The CTFLearn server is crapping out. That's okay. Hold on. I'll leave this alone. We'll go over to something like HackMyVM to see if we can solve a challenge or two. Well, if we can solve one challenge over there. Okay, I was awake and asleep, only seeing bits. No worries. Okay, so let's try doing a web challenge from this platform. So HMV grind. Yeah, okay, nothing new here. Challenges. Web. And let's see. We solved a few of these challenges already. Let's try 14. What is this? If you want to try this out yourself, CTFLearn is poopin'. Yep, sure. Okay, find the flag in the domain momo.hackmyvm.eu. Try to find the flag in the domain momo.hackmyvm.eu. Alright, well everybody, you are welcome to try. Let's take a look. What am I looking at? Logo.png, alt HMV. So we need to find a flag in here, huh? Alright, well, I guess we can do some fuzzing first. Where's my fuzzing? Is it... So maybe we'll run some derb. There might be something like, I don't know, robots.txt, we can check it real fast. Or sitemap.xml. We know that this is an Nginx server. The other thing we could do real quick is we could just take a look at the curl results. So curl this. We'll leave this alone over here. Curl v this. What does HS stand for as a directory name? Oh, that's HackerFrogs. Okay, so it's Nginx 1.8, 1.18. Okay, accept range is bytes. Alt HMV. I think... I mean, there's nothing here. I think what we need to do is we need to do a very thorough, like, directory busting scan. Because there's absolutely nothing on this website. Index.html. This is an HTML page. I mean, otherwise, the only thing that's here is this image. And if this image has something inside of it, then I'd be kind of disappointed. It's a PNG file. I mean, we could try downloading it. Okay, wget that this file right here, the logo, and then like exif tool. Okay, or we could what is it? So exif tool, there's also strings. We ran a lot of strings. So this is a PNG file. There's a big chunk thing. Everything looks normal. We could also zstag. Didn't get anything there. Okay. Unrar? I mean, there has to be some sort of indication that there's something there first, right? Okay, let's just look through this super quick. Okay. Yeah, no, I don't see anything super obvious here. Oh, you know what we could do? There was a challenge that that SysOS was taking a look at, and I'm pretty sure he figured it out. And we spent the last part of the previous stream looking at it. It was over at Hacking Hub. We could take a look at that. hackinghub.io. And this was for B-Sides Exeter in the web category. And this was read between the lines. The amount of CTF sites is insane. Yeah, there really are a lot of them. I'm trying to catalog these things. But I'm pretty sure the stuff that we're looking at is public. So open it in new tab. this one over here, if you want to take a look. So the flag can be found here over and over again. The name of the challenge is called Read Between the Lines. So what we're going to do is we're just going to, we'll try copying everything from here. So select all, copy, and then we'll write it to a file. So we'll call this readlines.txt. Paste it in. Okay, so SysOS said something about there being weird information between the different lines. So it can xxd on readlines.txt here, and one of these AI tomfoolery things. Omar says, regarding a HackMyVM, do a cite momo.hackmyvm.eu on Google. Oh, is it some sort of like DNS thing? What the heck? Password to obtain the flag? Okay, I mean, I haven't really done a lot of Google dorking before. I don't know, I'm just suggesting stuff. Thank you, Omar. Omar, do you work in cybersecurity? I get the feeling that you've been in the industry for a while. That's the feeling I get. Okay, there's ads running on Twitch. I really have not been doing a very good job. I haven't been doing a very good job taking my breaks. But here you go. Here's some birds. We're going to be doing a little water break for about a minute, but enjoy the birds and enjoy the music. I'll be back in about 60 seconds. Okay, so I hope you like the birds. These are fledgling stellar jays. They're very, very cute little baby birds. But anyways, let's put the birds away. Let's get back to the hacking. Hopefully we can figure this out pretty quick. So Untitled John Monroe Vault. I guess one of the reasons why I don't try to Google these websites is that the websites usually are not publicly available. Nothing with XFTool. No? I don't think so. What is this? Whoa! There's a random endpoint here that we never would have found unless we did like a Google search. Huh. Omar, geez. This was, John Monroe Vault? Wesley... John Monroe Vault. So it's user equals some number. User equals some number. I mean, we could do like a fuzz. We could fuzz this endpoint to try to figure out if we get different results. So here, password to get the flag. Password to obtain the flag. We don't know the password yet. Huh. Everything else is a name. Vault stands out as well. I mean, we would never... Okay. So doing like regular directory busting, we wouldn't be able to find directories like this. Especially not this. These are not it's not practical to look for this with directory busting. Okay, let's go into here. We only found index.html, of course. All right, so let's do our parameter fuzzing. So this is 404 not found. So user equals 1, user equals 2, user equals 3. Okay, so we're just going to do some fuzzing. So user equals everything from 1 to like 9,999 maybe? We can do this pretty easily with FFUF. The first thing we would do is we would make a sequence file, or a sequence of number file. So sequence 0 to 9999, and redirect that to sequence.txt or numbers.txt. Study bloggers. Hello, nice to see you here. It's Rama, different account. Oh, nice to see ya. What is up? How's life? Well, we're just here hacking stuff like we usually do. Okay, so we just need to insert this, user equals fuzz, or fuzz equals 3, like this. Okay, and then as the word list, we'll put in our numbers.txt. Okay, and we haven't gotten any hits yet. Well, I guess we need to wait a set. Cool. I wanted to ask if you've used LeetCode. We did, what is it? Advent of Code earlier today. It's kind of a similar concept. Thamy Paul, hello, nice to see you here. And I'm a noob. It's the domain, and I want to learn coding, and I'm a noob in the domain, and I want to learn coding and cybersecurity. What's your advice? So I love what you're doing, although I don't understand. Yeah, we've got a website that we refer people to. Get into cyber over here. Take a look. Okay, so fuzz equals. Oh no! I did it wrong. It's supposed to be user. User equal fuzz. Is it user or users? Yeah, user equals fuzz. It's morning in Dubai. Hey! Good morning to you. Hope you're having a good one. Okay, so user equal fuzz. Response status 200 to 299. This is also this is still not coming back okay. All right. So there's this one. Password to obtain the flag. Password test wrong pass. Password test wrong pass. So are we supposed to like fuzz this? Link is not working, brother. Really? It points to resources. It's in the source code. It's in the source code. Is my link not working? I mean, it works in Twitch. Let me take a look at what it looks like in YouTube. No, it works in YouTube. Let me pull it up again. That link says too many requests. Does it? Hold on. Too many requests. You have exceeded a secondary rate limit. Please wait a few minutes before you try again. Huh. Yeah, it says too many requests. Yeah, GitHub problem, too many requests. You might want to try it again later. It looks like it doesn't want to let people look at it right now. It worked for me now. Yeah. So 002. I mean, the other thing we could do is we could start fuzzing this web page as well, because it seems like the page title is kind of an indication that we could try fuzzing this. But you know what? We're gonna have to do this some other time, because it's getting kind of late. But let's take a look at who is streaming right now. Okay, so Unhacker in Capital is streaming right now. The last time I raided into this person's channel, one of the chatters decided to start sending me unpleasant messages. So we might skip raiding into this channel. Let's see who else is on Twitch right now. What are the chances if there's a 001 if there's a 002? I mean, maybe? Not found. 001, 002 is valid. 003 is not valid. Okay, so here's what we're gonna do. We're gonna raid into the science channels, the science stream, because they do science. Actually, also Moohiddles is streaming right now, and she's usually taking looks at some pretty fun stuff on NASA. Let's take a look. Do you have any advice for somebody who is learning cybersecurity and has a decent networking knowledge? How to improve fast in the field? I'd appreciate any help. On TryHackMe, I mean. Well, here's the Discord. Here's my Discord, and here's my Reddit. You can. Why don't you try sending me a message on there, and I'll try to answer your question as best I can. Okay. Okay. So this Moohiddles is on break right now, so we'll take a look at what Science Stream is up to. Okay, Science Stream is doing science stuff. What science stuff is it? So, Together for Women in STEAM featuring I Paint Burbs. Okay, great. Alright, so we'll raid into this channel. Raid Science. Science Streams. Okay, when you arrive on that channel, if you could give this message over here, OSFrog, Hip Hop Hack OSFrog, I would really appreciate it. Okay? But before we go, let's talk about what we're doing next week. So next week, we're going to be streaming on Wednesday and Friday. We're going to be continuing our Python lessons. We're going to be doing some gaming. We're going to be doing some Python. We're going to be doing some easy challenges. We're also going to be doing a CTF box challenge called Doll on HackMyVM. And we're going to be checking out a new website called Hacking Advisor. So there are all sorts of these new websites. We're going to be checking this one out. And yeah, so please come back on Wednesday, and we're going to be continuing our hacking journey. All right, so everybody, thank you very much for coming today, and have a great weekend, and we'll see you next week. HackerFrogs out in 5, 4, 3, 2, 1. See you later.